day you'll be like droned out. I know I will. At least for the weekend. We'll start with the drones again on Monday. Day 3 in the coffee today is sponsored by sUSBExpo, which was nice of them. There is no lunch. There's nothing else. There's no more frills. No more free beer. Did everyone go over the transit last night? That was nice. That was nice and very nice and casual setting. And the weather. For everybody who's not from San Francisco, the weather yesterday was like $1 million weather. Where you could walk around in a shirt sleeve weather at 8 o'clock at night. So I enjoyed that too. Again, our sponsors. But we're going to launch right in here. We got a half day. We're going to start with Allied Drones. And Steve Smith is going to do the presentation for that. So welcome, Steve.
Okay. Thank you very much.
There's a laser.
Oh, there's a laser. Yeah. Good morning, everybody. Glad to see you here this morning. Patrick, thanks for putting on a great event. Wonderful time, lots of good information. My name is Steve Smith. I'm the president of Ultravance Corporation. I work with a number of companies in the strictly UAV and UAS space, and engineering for aviation to my equipment sales. I've been the top salesperson at 4 companies, vice president twice, director of sales twice. The largest one was the 3rd largest sensor manufacturer on Earth, and I was responsible for the Western Hemisphere in Asia. So today, what I'm doing is I'm working with specific technologies that are particularly interesting. And if I think that they're really profoundly useful, then I'd like to get involved. So today I'm here talking on behalf of Allied Drones. We'll see if I can advance through these slides. Allied Drones is located in Huntington Beach. Being here the last few days looking through these windows, it's a wonderful view. We like to think that in Huntington Beach the view's pretty nice as well. We're located just off of the Southern California offshore test range. So the reason for this slide is you can see Santa Catalina Island and San Clemente Island. A few years ago, I was involved in some UAV operations off San Clemente Island. With the 3rd fleet. It was a lot of fun. And our proximity to that is, as you can see, Huntington Beach is in the upper right-hand corner. That's the new Allied Drones facility in that building. So as pretty as it is here, we like to think Huntington Beach has its benefits. Josh Kornoff founded the company several years ago. He's a special effects specialist. He's been doing that for years. And several years ago, he needed a shop and he needed a platform. And that was kind of his introduction into the world of UAVs. Josh is here in the front row. I may call on him a little bit later, but that was the genesis of Allied Drones. The company does a lot of interesting things. The EF-44, which is a large craft, I don't know if did anybody see us on the first day when we had the EF-44 here? It's about 4.5 foot. Across diagonally across the craft. It's a large craft, flies for an hour. Also a fixed wing craft called EOS, 20-pound heavy lifter crafts, multi-rotor coaxial, and then a number of interesting other solutions of Allied Drones, such as this gimbal, which until this week had never been seen in public before. Carbon fiber, fully enclosed, no exposed wires, where the direct drive motors are. So that's what Allied Drones does, in addition to what I'm really here to talk about today, which is a different subject entirely. Because we're not really going to talk about any of those. Because it's early in the morning, or not really early, but because I'm the first speaker on Friday, I thought we'd start with something like this. You know, the nice thing about UAVs is we're not subjecting the pilot to the stresses of this kind of maneuver. Wonderful to watch. If you're in an air show, you know, launch shabogs, double Himmelmans, barrel rolls, loops. But the positive and negative G's that the pilot is enduring is extreme, right? But it is something that we can do with the UAV pretty well. We don't have to subject people to that kind of torture, really. But the reality is, I'm not going to talk about that either. I'm going to talk about this. When we think of a UAV, we think of something that covers ground. It goes from A to B. You know, it's latitude and longitude. It does things that are pretty fun, mapping, you know, agricultural applications, etc. This craft is not that. This craft is an elevator with a wire. It goes up and down. It's not aerobatic. It's not, you know, particularly sexy in a lot of ways. What it is extremely functional, and it's an interesting kind of a product because it'll fly for days. It's not, its endurance isn't measured in minutes or hours, it's measured in days and weeks. So when you put up a tethered UAV, it'll stay up, as long as you can provide power from the ground. Power comes to it via that 2 millimeter wide, 2 millimeter in diameter power cord. It's got a Teflon sheet around the outside. And the maximum altitude is 120 meters, so 390 feet. Just 10 feet shy of the FAA limit. One of the benefits of a tethered craft is you cannot have a flywheel situation because when the cable breaks, it's coming down. We provide about 300 watts of power to the payload. And in a situation where all you want to do is go up and down, and there's a lot of them, I'm just give you an idea of how you use a tethered craft, because it's like people are not thinking about tethered crafts as a general rule. But when you start to look at it, it's interesting. So if you're in a situation where it's a vertical environment, real good application because you can take a real close, long, hard look at blades on a wind turbine, for example. There are alternatives. You could be that guy, right? And he's tethered too. But the reason why that wind turbine is where it is because it's a windy environment. Not a good place to be out there hiking around looking at these blades. Just because a natural question would be, okay, so it's a windy environment, can you fly this tethered craft in that environment? We were flying a few weeks ago for demonstration, and the windsock, to inflate a standard windsock is 17 knots. And it was gusting to probably, I don't know, 50% more than that. The HV44, we call it HV, was rock solid. And again, we don't want it to do a lot of traveling. We want it to maintain its latitude and longitude, its exact GPS location. Another application is bridge inspection. So if you were going to inspect this bridge, you know, you might have a platform that floats in underneath it and you go up and down. You might put something in the water, go up, and you might recall down. Or you might do what people do a lot of, and that is they have a very specialized apparatus for looking at bridges. How would you like to be the guys at the end of that cherry picker? Okay. Very expensive piece of equipment. Logistically, it's hard to move around. Sometimes things like that happen. How would you like to be the guys at the end of that cherry picker when the truck turns over? Okay, or you could just fly a little HV44, comes in a Pelican case, and you're up and running in 5 minutes, and you can do a lot of the same kind of work. Or, here's another one. Let's say that you're in a draw fighting a wildfire, and you're in a potential burnover situation, like you know happened in the Prescott, Arizona Fire Department. 19 guys were killed right 2 years ago in that situation. They had a comms issue, among other problems. So if they had been able to launch a tethered craft from the back of that Hummer, they could have maintained their comms. It would have been a real good application for them. So there's a couple of pictures of situations where if you're in an environment where you can't maintain or establish line-of-sight communications, you put a repeater in a tethered craft, you're up 40 stories, you have a mast, essentially you have a radio tower 40 stories tall in 5 minutes. And the next picture, I'm going to show you this. This is Mount Diablo. You say Diablo or Diablo? Yeah. Diablo. Okay, well that tower doesn't exist because it got burned over. It's a ham repeater tower. Once the fire sweeps through, you can drive right back down that road with an HV44 and a repeater, same sort of similar situation, put it up and reestablish communications. So again, it's basically an airborne elevator. But the sorts of things you can do with that, especially if you can keep it in the air for days, are very useful. It's inexpensive, it's easy to use, it's very simple to fly because it's basically up down. You don't need really to have a lot of training to operate it. Half an hour is probably adequate. The generator we use is a 2,000 watt Honda, $999, runs for 9.5 hours and a gallon of gas. Now I'm just going to give you an idea of what it takes to put one of these together. So this is actually Josh that's doing this assembly. So you just pull out the power supply, pulling out the fuselage. It's square for a reason, so that it can accommodate mill standard 1933 rails, top, bottom, and the sides of the fuselage. So it's got Picatinny rails that can mount payloads to very easily. Each outrigger, pre-equipped with the props and motors. It's one set screw, and then one single electrical connector. So I think we're into this now, maybe 30 seconds. So I'm going to put on another outrigger, another set screw, another electrical connection, and then it'll be time to connect the umbilical, connect the tether here in just a moment. You can put fiber optics in the cable if you want, in the tether, and then you have massive amounts of bandwidth available, depending on what kind of sensor you're gaining. Okay, and then you're there. You have to initialize the software, you have to plug it in, you get the generator running easily, 5 to 10 minutes you're in the air. Okay? So one of the other applications that's real popular right now, or at least in discussion, this is kind of new technology for allied drones. There's a lot of interest in it. Comms repeaters, real common, a lot of that going on right now. But you can also use this as a mass extension at sea. So if you want your little portable HV44, again from a Pelican case, now you can have much greater range for your antennas beyond line of sight. Horizon's 3 miles from your vessel. With this, you extend that dramatically. Wildfire we talked about, firefighting, Wi-Fi networks, mesh networks. There's a lot of discussions about that right now. Structure inspections like wind generators, bridges. Another thing is some facilities need to establish what are essentially sentry towers, but they need to do it quickly. It's a forward operating base in the military environment, for example. They can do that with an HV44. They can fly it and have a ISR situation almost immediately. So you can put an EOIR camera on it, day-night camera. And then there are other payloads, interesting payloads, such as putting lights on this and flying those. So 300 watts is a lot of power. Again, it's pretty much unlimited. So we talked about the firefighting problems. How often does that come up? I mean, we all know about the Arizona situation because it was the worst loss of life since 1935, I think it was, which is Griffith Park. So it was the worst loss of life for firefighters since 9/11. That was just 2 years ago. But how often does it happen? Well, it turns out they lose a fair amount of equipment this way. So using the HV44 is definitely better than the alternative. Better than not having one. And it's simple and it's relatively inexpensive. So that's a tethered. I guess my point in all of this is not to be just specific to allied drones, but tethered UAVs are particularly useful for the right applications. Are there any questions? Yes, sir.
Tethered has been talked about for a while, but what do you find your payload efficiency is in function of altitude? So you got to carry that some building.
So, do you mean in terms of power consumption?
Power payload capacity, just weight.
Oh, okay. So the weight capacity is 2 kilograms, so roughly 4.5 pounds, 4.4 pounds. And the repeaters, interestingly, these UHF, VHF repeaters, which are self-contained, and then the beauty of it is we can also feed it with power if they want, but we can just fly that as it is right now, at least 1.7 pounds for a UHF, VHF repeater.
So can you still clarify how much weight do you add full?
It's the same weight. It's not significant enough. Josh.
The tether, that full weight,
So it's really the forefront of the concept for.
Yes.
Thank you.
The other thing, the other condition that I think keep in mind about the tethers is the drag that they induce, the induced drag of the wind. So having it at 2 millimeters is a big thing because it doesn't produce a lot of drag, which could be an issue. So hopefully it's just something technology to think about. Any other questions? Okay, thank you very much.
Now look at that. Okay. So we'll just take that out. All right. So we'll move on to the next speaker, which is another one of the old guard. Well, yeah, whatever. Did I? Yeah. Okay. We got another presentation. Let's see here. I'll get it out of my head. Yeah, I didn't get a chance, but I might be down here. Can't climb up on the stairs. Yeah, use the stairs. You got it right there. Let's see. That was easy. We'll just roll straight in right here. Oh, look at this one's even fancier. Anyway, I've known him down here for a little while. We were on the small unmanned systems ARC. That's where I first met you, right? Together, and we got together for 10 months in the Gladiator pit together. So please welcome Doug Marshall.
Good morning, all. Thank you, Patrick. I'm surprised anybody's still here. My compliments to those that gave up the one for morning to be out all day to come in here and finish up. Patrick asked me to talk about ASTM standards. Just by show of hands, how many folks here in the room are members of ASTM? Not one, okay. Maybe there will be. Move along here. ASTM is a full disclosure, I actually borrowed this presentation from Ted Wierenowski, who is the chair of ASTM's F38 committee on UAS. For those of you who may be going to Atlanta next week for EUVSI, Ted will be basically giving the same brief in a more expanded version. He is the chair, and I'm, as I'll show you in a few moments, chair of the subgroup. ASTM is an organization that's been around for over 100 years. It's a consensus-based volunteer organization. They set standards on a variety of industries, way beyond aviation. Actually, the first standard that they created was the width or the space between rails for railroads. That goes back to the late 1800s. Everything from the configuration of electrical outlets on the walls to how many liters of water are flushed out the toilet, everything across the board. Medical standards, medical devices. They literally have thousands of standards that are out there that have been reached through consensus operations and have been adopted across many industries. And this is kind of just a propaganda for the organization, but they really do touch every aspect of your life. There's anything that there seems to be a standard size or a standard configuration or a standard speed or a standard shape of probably came out of ASTM or one of its sister organizations, SAE or RTCA. There's three big organizations that do this sort of work. And the way that the work gets done is basically folks like you volunteering to participate in the organizations and helping to set the standards. Why are standards important? For especially this industry, it's evolving and growing as fast as it is. There's not a lot of consensus on what these things should look like, how the configuration should be harmonized if they are to be. Every aspect, every component of the UAS comes from a variety of sources. There's really no standards out there that define what they should do, what they should look like, what their capacities are. As it says here, there's 12,000 plus standards operations globally. They draw from virtually every field of science and engineering, law and policy across the board to get people involved in setting these criteria. We rely on members' expertise. You don't have to be an expert in anything to be involved with ASTM or to join one of the committees. All it takes is paying $75 for a membership. You can go through a list of committees that are out there. The website for ASTM is ASTM.org. It's very user-friendly. You can find a reference to a standard and just anything you can possibly think of. And if you have an interest in participating in any of the standards work, whether it's UAS related or something else, all you got to do is sign up. That's all it takes. Put your name out there for a committee, and at some point you'll be contacted. Some of the committees get rather large, other ones are small, task groups that do very focused areas of research. And as you become known and become more active in some of the committee work or demonstrate an area of expertise or interest that will benefit the larger organization, you may be contacted by a committee chair and asked to join a task group or a subgroup group or lead one. Most of the work is done over the telephone or through emails. We have, at least our committee, the F-38 committee, we meet a couple times a year. The next meeting is in Atlanta. It's start up to AVSI. It's a all-day event for F-38. It's all the F-38 committees and subcommittees. We last met down at Mexico State, the TAC conference last December in Albuquerque. And we'll keep going until all this is done. If you happen to be in Atlanta, it's an open meeting, you're welcome to sit down on it. I'm not sure what room it's at, but it's a pre-meeting to the big conference. The standard aviation standards, as you well know for most of your experience, done the whole broad spectrum of standards and regulations from the completely exempt category on the left over here to the highly regulated on the right to the airline industry, and then a lot in between. And where UAS kind of falls into this matrix at this point is sort of either here or here, and trying to come, and it's consensus based. It's the FAA adopted industry standards not to endorse. And as the cause me, these standards are not regulatory. They're not enforceable by the FAA. They can't take you to jail or take away your airman certificate or your 333 exemption because you violate one of these standards. It's a standard that are being proposed to suggest ways, means of compliance with the regulations or the prescriptive rules that are out there. It's something that's not on this brief, but I think it's important for you to understand. There's been a lot of talk about best practices, standards, and insurance in this conference, and that's a hot topic right now, is how the insurance industry proposes to underwrite the risks that are inherent in UAS operations. I can tell you that a lot of the underwriters and carriers out there really don't know how to assess the risk in this technology. It's kind of a scary prospect to write an insurance policy, not for a whole loss necessarily. That's fairly easy. It's the liabilities that may come out of it. The way that standards may work into that insurance or legal process could be that if there's an incident or an accident with a catastrophic result, a serious injury or death, inevitably there's going to be lawsuits out of that. And one of the ways that the legal system assesses liability or culpability in a civil environment for civil damages is if there's a standard practice or a best practice. What's the best way to do this? And if there's a standard out there that you're either not aware of or you've chosen to ignore, that can be used against you potentially in a court of law. And that's not something that you want to try to face. So if there are standards that are out there that are specific to what you're trying to do, the best idea, the most cautious idea is to try to comply with it. Might save you something down the line. So the vision of F-38 was to provide routine, safe UAS operations in the civil airspace through standardization. The products that the committee has considered is design, manufacture, maintenance, operation of unmanned aircraft systems, and then pilot training and qualification. The structure now of F-38 is actually divided up into three large committees. F-38-01, chaired by A.J. Segal from, I think, Wild Aerospace is his employer. It's oriented towards hardware, safe design, construction, test, modification, inspection of individual components, the aircraft itself, and the system, which includes launching devices. We're talking about tethered UASs, perhaps a standard for the strength of the tether. There's a lot of things that go into that. That's an ongoing committee right now. We briefed again at Atlanta on Monday. F-3802, flight operations chaired by Mark Blanks at Kansas State. This is a performance-oriented, performance-based standard effort. The attempt to get safe deployment of the system within the aviation environment and integrate it with NAS. Real tough effort right now going on to try to sort out all the components. And then F-3803 is personnel or crew aid and pilot training, basically. Scott Morgan is the chair of that. All three of those individuals will be in Atlanta. If you have any interest in perhaps joining these efforts, I suggest that you try to look them up and introduce yourself. The history of how F-38 or ASTM got involved in the UAS effort and the NPRM comes out of the beginning of the ARC. Patrick mentioned that he and I were on the ARC together. I see Rich Hansen's not here. Rich from the Academy of Aeronautics on the committee. There was about 20 of us in the ARC. And that organization became a volunteer. We were all asked to serve by the FAA. And we met for just about a year all over the country. It was a traveling roadshow. It's kind of like an antiques roadshow. And we met at least once a month at some location around the country. We had actually demonstration days, once out of Dryden Research Center here in California, another one in Quantico, another one at Pax River, where we just get demonstrations of different systems just to see how they operate and some of the issues were. We issued our recommendations in April 2009. For those that have sat on the committee, we've been waiting with bated breath for the rule to actually come out. Even though we wrote the recommendations that underlie the rule, we were not allowed to actually see how the rules being developed. They kept that away from us and everybody else as well. In September of 2009, the FAA then sent out a solicitation to the standards industry, to ASTM, SAE, RTCA, and other organizations to see who would be interested, or which organization would be interested in trying to put some standards together that would support the rule of the NPRM. And ASTM made a pitch. The FAA provided some funding for that. And they came up with a memorandum of understanding in April 2010, where the ASTM stood up the F-38 committee for standards supporting the NPRM. So the answer. So from April 2010 to just this last February, the committees, local committees, developed and published a set of 7 standards, and these are the categories: design, construction, and test. The number that is next to that in parentheses is how you would find these standards if you go onto the ASTM site. These are not publicly accessible unless you're an ASTM member. If you pay the fee, then you can pull these standards up, and you're available to design and C2's subsystem It's another committee than the use of batteries, not the design of batteries, but battery usage, safety issues, flammability, exploding batteries, that sort of thing. Then production acceptance, quality assurance, maintenance, and continued airworthiness, and an aircraft flight manual. Not a training manual, but an aircraft flight manual, like electronic flight bag, like airlines use. So then, here this last February, then, of course, the FAA issues its NPRM, and after having chartered the ASTM organization to stand up these standards behind the rule, they said nothing in the NPRM about ASTM or standards, and couldn't tell ASTM or anybody else involved in this effort why they made that decision. I still don't know as they stand up here. I'm hoping to get an explanation next week, but I can tell you, it's kind of distressing to all of us to have put in the amount of effort and work that's gone into these standards. We meet every week. I chair a committee, I'll tell you about that. And in fact, we're supposed to be meeting today, and we aren't, because I'm standing here talking to you. There's another committee that I sit in on yesterday. We meet every Thursday. It's a weekly thing. We have terms of reference that we deal with that have been written by the FAA. The FAA has a liaison that sits on each of these committees. As an official voting member and somebody who is providing feedback and some guidance to us as to what the FAA is thinking. As the NPRM was being developed, or the rules being developed, without anybody knowing what it was going to say, including those of us who wrote the recommendations, we were working around that on these committees, the standards committees, to try to create standards of compliance or best practices documents to support a rule that we didn't know what the language was. And as close as we could get to that information was the FAA liaison who would say, if we got real specific about something, that looks pretty good. Yeah, no comment, so that was code for us, and that was okay for us to go down the path. Or they might say, well, you might want to consider this, or you don't want to go there. They couldn't give a specific direction at all. There's an ex parte rule that prevented them from sharing with the outside world, including these standards committees, the actual language of the text of the standard or of the rule. And so we were kept in the dark through all of this standards development process as to what the rule is going to say. And I can see the looks on some of your faces thinking, how can you possibly operate in an environment like that? I tell you, it's not easy, because we were trying to anticipate what we thought the rule might say. Most of us that were on the ARC, the original rulemaking committee, had a sense of what the rule was going to say because we wrote the recommendations, but that didn't mean it was going to come out like that at the end. So we worked through all that, tried to anyhow. What the final rule is going to look like, we don't know. You don't know. All the comments closed last Friday. I assume some of you probably submitted comments, something like 4,000 or 5,000 or something like that. For all of these standards that have been developed, and 7 of them have been published, the first 7 I had on the list, when the rule becomes final and the FAA's worked through all the comments and all the resolutions that they have to work through, then each of these committees will at least have to go back and look at the standard they've developed and revisit them to make sure that all that 3 or 4 years of work actually is consistent with what the rule says. So everybody, each of these committees is going to have to go back and take another look at it. Other subgroups and task groups are in the process right now, trying to write standards to support the rule now that we know what the rule says, what we think it's going to say. 5 other standards are in development right now. These include operations over people. It seems to be a big concern to everybody. That's what everybody wants to do, is operate over people. I'm the chair of that task group. We've actually been a task group for 2.5 years. We've gone through 3 iterations of our tasking and our scoping document from the FAA. We got a new terms of reference about 2 months ago that literally completely changed the direction of what we were doing. So everything that we had done up to that point, we learned from it. I can't say it was a waste of time. It certainly wasn't, but it was frustrating to have put in the effort that we did, and then we handed a new term of reference and said, let's do something else. So where we're headed right now with the operations over people is a best practice process, not specific prescriptive rules, that's another committee's job. But a process for folks like you to go to the FAA, either seeking a 333 exemption or a 2117B special class certificate or something else. And that's a big word. There may be something else out there. The FAA has other things in mind for ways to get the commercial operators and folks like you to get you into the airspace and make some money. That's their goal. They need to do it safely. So these other task groups are trying to put rules in place that will allow it to happen. Extended and beyond visual line of sight has not been stood up yet. It's going to be. We're getting close, but 2 minutes ago, I can wrap it up too. Operational risk assessment led by Harrison Wolf of USC's aviation safety program chairs that task group that's going on yesterday. And that's also a process-oriented standard. It's how to go about doing what you need to do without answering the questions for you. It's more suggestive of the questions you should be asking. Marking, which hasn't started up yet, in the certification of pilots and visual observers. Continued participation in ASTM US standards is highly encouraged. You know, I'm making a sales pitch here, but if you want to help establish what the best practices are and what the standard for operational integrity should be, join one of those committees. Pay the fee and get involved and put your voice out there so that you can be an advocate for whatever point of view that you might have. On our operations over people group, we have one academic. I'm not going to name anybody, but very well known for the work he's done in atmospheric science all over the world. A law enforcement guy, in fact, 2 law enforcement guys. One of them really famous because he's done his thing all over the world, chasing poachers in Africa. He's really been a leader in this. The other one's a county sheriff, is also an academic. We have a representative of a major U.S. manufacturer, I won't name. We have an airline pilot, so he's got a point of view. It's very direct and specific to what he wants. Another fellow is a software engineer and forensic specialist who is an RC guy, but his thing is computers, hacking, that sort of thing. He's a genius. He's got a 12-page Wikipedia page for stuff that he's done. It's got nothing to do with this industry. He's part of our committee. He's very useful. And who else? Rich Hansen, who's the AMA guys on the committee. So there's 8 of us. And we're hoping to finish our work soon. So again, I would encourage you, if you have an interest in not only seeing how this works, but actually having an impact on the outcome, pay your $75 and join the committee.
Well, yeah, is it much more productive since I'm not very throwing monkey wrench and everything?
Well, we have your avatar. Patrick. We have other people who throw monkey wrenches. Your name comes up a lot during committee.
I've heard that.
Yeah. Somebody will say something truly outrageous and say, well, that sounds like that. But that's okay. Every good, healthy organization needs to have dissent. This is the way it
Is
goes.
that what we're calling it now?
Well, as long as it's polite and don't make outrageous accusations. No, you have to have every point of view on the table. And the underlying philosophy of ASTM and the other standards works are, it's a consensus-based process. Consensus means consensus. We can't come to an agreement on any element of what we're doing, then we don't publish it. We have to agree. If we can't agree, we can't agree. And there have been elements of the committee that I chair that we simply cannot agree on. So we table it, put it in a parking lot. And things are changing so rapidly in this industry, not only from the FAA, but just technology-wise. I have to refer back to the original standards group, the original 7, that got worked on for 5 years and published. They never considered rotorcraft or multi-rotors because it wasn't on the table. They started different. Now they got to go back and take another look because that's the thing now. It's the multi-rotors, the fixed wing. They solved that very thing, but not the multi-rotors. So it's an iterative process. Any questions? I didn't put my contact. These are the 2 guys to contact if you want to join.
Sure. When is the ASTM meeting in Atlanta?
It's Monday.
Monday,
Monday, all day.
all day.
Yeah. It's in a room, I can't remember, it's can't think of the name of the room, but there'll be a big sign up for that. It's an all-day deal. It'll be open. It's a pretty large crowd. There's 11 committees that are on there. Paul Delapovitz is the membership secretary. Contact him. Ted Rubinowski is the chair. Ted will be around, of course. My name is Doug Marshall. If you want to contact me, give me a card afterwards. Thanks for listening.
Yes, I appreciate that. It does happen. It's beautiful. All right. I would say that if you did get involved with the ASTM, there's a lot of good people there, interesting people. I mean, you'll really meet, like Doug was kind of alluding to, you will meet some real professionals. Ted Rubinowski was test pilot for the X-29, which was the jet with the wings pointing forward. So some real interesting people. I had a little bit of an issue with ASTM. I guess I was kind of early there, and the only people that were really in on it were the big aviation companies, the DoD vendors. But again, with that, there's definitely more diversity as smaller companies are getting involved with that. So if it's something you want to work on, meet some good people, good peers, good connections, it's something to check out. Our next presenter is another guy that I've known for a long time. He's been in the ecosystem all the way from Norway, Mr. Knut Moe.
Actually. You have a group on the internet. Hi guys, nice to see you all. My name is Knut Moe. I work at Squarehead in Oslo, Norway. I'm here to give you a presentation on drone security threat assessment, or today we like to call it Paranoia 101. Welcome. So what we do in short is that we are audio experts. We've been dealing with audio for many years. What happens is that drones emit audio when they fly around, which is really hard to spoof, hard to conceal. So I'm going to give you a little bit of an introduction into why and how over the next couple of slides, and I hope you enjoy. Our company was established in 2004. We are working out of Oslo. That white stuff you see on the ground there in front of the building is actually snow. It was what rain turns into. It's really cold and nasty. We are about 25 people now, and we've been working a lot with industrial detection and also law enforcement for quite some time. Our core knowledge is about physics of sound. Sound physics is an interesting field. I'm not going to get into that today, but I could talk about it for some time, for anybody that's particularly interested. I've been running various drone operations for the last 5-6 years in various parts of the world. So I have some experience with drones, to say the least. And before that, I was working with threat assessments and how to mitigate threat on secure locations and stuff like this for Norwegian government and Norwegian industries. So what do we do? Industrially, we are able to record something by pointing one of these microphones at whatever we are trying to hear, and we were able to visualize where the particular frequency of the sound we are trying to hear is coming from. So for instance, when Volvo Trucks had a problem with one of their engines, and they were thinking about recalling over 15,000 trucks, which is a staggering cost to them. We had one of their engines in a echo chamber where we were listening to various parts of the engine, and we were able to pinpoint the exact spot where the problem was by using audio down to a square inch. So they knew where it was and they could fix it out in the field instead of calling all the trucks into the factory, which could have been a cost to them. So we were able to localize different sounds and different frequencies to different parts of the engine, for instance, and that had us thinking a little bit. Because I don't know how much drone media you're reading these days, but even if you're only reading SUS News, you are seeing that there are a lot of people using drones for good, but there are also some of them are using it for a little bit more creative approaches. So these days, if you're running a prison or if you're running something that you want to remain secure within, or keep people inside or keep people out of for some reason, it's fairly easy to smuggle a little bit of drugs, phone, knife, small gun into an area and have it picked up by people in so that's not supposed to have that contraband in their hands. And this is becoming an issue because, roughly, as far as I can tell, roughly 200,000 units of drones are sold every month all over the world. And it's rising, and there will be more and more. And I don't want to guess the percentage of people that have some bad ideas, but if you say 1%, it's still 2,000 people per month. That's a pretty low number. I'm working with the Norwegian Drone Association. We're not a huge organization by all means, but we are there. And we are 300 members. That accounts for roughly 1% of the drones that has been registered in Norway. So we're seeing that a small fraction is operating on a registered base. Most of the people are just buying it online and flying and having fun. So it's an industry without oversight and open to anyone with no vetting, which means that there is a problem. So a little bit about drone capacities. I've given this presentation a few times to people that do not know so much about drones. Excuse me for this particular slide. I just did a quick check. In Europe, I can buy a drone that carries 70 pounds off the shelf of a small company, and I can fly it within a day, and I can have fun with that. And that's 70 pounds. They also have a model that requires specific ordering, which will lift roughly 240 pounds. And we still talk about a quadcopter. I can't imagine how angry that will sound as flying, but still it's there. And 240 pounds is quite a bit of material if you want to do something bad, all right? So what we did is that we sat down and took on our black caps or hats and tried to figure out what could I do if I had some evil intent. And we divided this into 5 core threats. This is mapping. It doesn't sound so ominous, does it? But it's actually, you can do a lot of stuff with it. It's situational awareness, it's smuggling, hacking, and terrorism. Those 3 last ones also pretty much scares a lot of people around us working with security. Because systematic mapping allows you to create an oversight, an overview of a location. So if you're running a military base, or if you're running a prison, or if you're running something that you don't want really exposed on people that have bad intent, this is really easy to do. It's for me to buy a drone, a camera, and the software. And I push a button and it flies over there every day. We did a test. We can collect license plates of every car in the parking lot inside a secure fence every day to see who's there, who works there. We can hook it up to a federal database that spits out the name of the person that owns that car. And you can start doing credit checks on that person, and suddenly you have an overview of who inside there are most likely to be interested in having a chat with you about money for information. Situational awareness, you're all aware of that. It's fairly easy to fly in somewhere and take video, take pictures, and see what's going on. So that's a no-brainer. You don't want to be able to have people do that without you knowing about it. So smuggling, this is fairly interesting. I think you all seen a lot of stories about smuggling over the last couple of months. Down in San Diego, they're quite close to the Mexican border, and you have people that want to move some piloted goods into the US. It's of course much better if they aren't punishable, because nobody can track who that drone that flew the piloted stuff over the border came from. It just flies over there. 1 out of 100 probably crashes. So you read about 2 or 3, and you can imagine how many didn't crash. If you now cross that with the fact that it can carry 240 pounds, it kind of gets interesting. We've seen Amazon. They've done some delivery of goods. They're waiting for regulations. I can assure you that the people that move contraband do not wait for regulations. They are doing it anyway. So it's a no-brainer for anybody that wants to move contraband into areas where they shouldn't be. Now the interesting part of this also goes the other way. So if I'm inside a secure area and I have something I want to get out of there, it works in reverse. I can easily pick up, go to the electronics store and buy a 2 terabyte drive that allows me to download anything that's within my reach inside the network and fly it out without going through the security checks. This is a prison in Norway. This is what it looks like. It is a 5-meter wall, 15 feet wall. That's a barbed wire around it, but it's really open. You can quite easily see here that there is a soccer pitch down at the bottom of it, and there are some trees right next to it. I do know the geolocation of those trees. I can go to any area within, let's see if there's a laser here somewhere. I can go to any of these areas and fly automatically into the prison and drop off whatever I want without anybody seeing it. Which is, I'm not doing that, so please do not run for me. I'm just saying. Now these are things you probably thought about, but what about this one? Computers and networks around any kind of operation that works seriously with any kind of confidential information. Now, the most secretive organizations are certainly a little bit off from the roads, and they're a little bit withdrawn from public sight. But there is no problem for me to go online and purchase a router that's specifically configured to exploit vulnerabilities within your network. They are routers that work in such a way because computer experts that do security checks use these systems to figure out where the problem is, and they do work. And if there is something wrong with your network, these routers will find that vulnerability and it will give you access if you have a black hat on. Right? The best locations for these boxes would be really near the network. It would be on the roof of the building where you have total, you're not seen by anybody. You're able to park this device there with a battery that lasts for 10 to 15 to 30 days. And if you find that vulnerability, you have access to all the data that goes through the network. That kind of sucks if you're running the network. You probably heard about AMC caches and false GSM base stations as well. Raise your hand if you heard about that. There we go. What they do is that they make a false base station that allows all the phones that's within the range to get hooked up to that base station. Now suddenly you're a man in the middle because you can create a connection to the outside world from that base station and relay the calls, and the guy on the phone doesn't know anything because he will see the regular phone network and he will see that everything is working as normal, but you are listening to every call that's made through that base station. And that scares the crap out of most of those companies because a lot of companies are stopping to use fixed landlines due to the fact that everybody hates them now because everybody's not sitting down in their office anymore. They are out traveling or somewhere else or they're meeting people, whatever. For me to operate a drone and fly this base station on top of your office is really easy. That also is something that one should be aware of. Can I have an example here with explosives? These are the Mythbusters. We are in the right place for that. This is 1 to 2 pounds of C4. That's 2 pounds. It's carryable by almost a DJI cannon. We can have a much bigger drone carrying much more than that. And it's pretty easy to imagine the consequences of putting something like this within the range of something that shouldn't be close to something like this. I can fly at roughly 50 to 60 miles per hour. I can come in from the sun, so nobody will see it coming, and it will be there with 4 or 5 seconds in the morning, which is not enough. We do have some tests. I cannot show you that, but I can show you Mythbusters because everybody loves the Mythbusters, right? There's a chemical mix that burns at 4,000 degrees. This is 2 pounds of C4. Excuse me. This is 2 pounds of the mix. It can be remotely triggered, and it can burn through the engine block of a car. It can burn through anything that is made of metal and ignited. These are 10 thick aluminum sheets. I can buy a drone that carries 240 pounds. Now, this should scare me a little bit because you have a lot of different installations that are not used to thinking about these threats. This is an oil refinery in Norway. It's one of the biggest. It has a small fence, but they haven't thought about the fact that you can fly over these fences, and neither has any other oil installation I've spoken to, which is a danger. So when you talk about risk analysis, probability is dead because you cannot, should not, and you will not use probability as a factor when you're dealing with risk. You have to think about the value and the vulnerability. If you have no real probability data, you must change your mode of thinking because you cannot use probability as a factor. You must use value. The value is what would be the cost to you if something would happen to your resource. What would be the real cost to you? What would be the immediate cost to you? What would be the loss of reputation or the loss of actual installation resources? So this is the background for us. What we did is that we figured out that our directional acoustic sensors, we actually able to hear these things, which is pretty cool. How our microphones work is that you have an array that creates a very narrow beam, so we can really hear what's going on. And we can provide a bearing and an azimuth to that object. So you all know if you have 3 bearings, what you get then? You get a triangulated position, right? So you can also figure out where exactly that piece of flying object is. We also collect the sound, and we are figuring out how to classify the different systems by comparing it to audio library as well, so we can know what's coming in there. This is a live test done with a government agency. We're listening. There's a drone alert now. Here, you hear something, and as soon as it comes close enough, it shows up with a crosshair. It's at this site, at this bearing. We can track it. We can see what's going on. We can see where it's moving. Pretty cool. We've done the same thing at night. And of course, sound doesn't work any worse at night, so needless to say, it works just the same. You get a drone alert, and you get the relative position of that drone, and you can start to figure out where is it, what can we do with it, what's our next item on the playlist. And what you do is more a matter of what kind of installation you have. For most, it's just enough to know that something is there, and you can take the necessary actions. For some, you want to employ an equipment system of some sort, but we're not dealing with that, unfortunately. So, to end it all, what we do is that we detect lightweight UAS before they become visible to the eye. We are able to do that by using audio and virtually unspoofable method. And it fills up a gap in the counter surgeries that are already out there. So we are working on this. Looking forward to show you the first commercial installations. They will be coming later on this year. But I would also like you all to keep all this in mind when you're talking to security customers that are not thinking about this bad. That's about it. That is spirit, and that's what I have to say. Thank you.
Question?
Yeah.
If I understand correctly, you guys have built a business offering as a service the perimeter monitoring. Is that correct?
We are not in a commercial realm quite yet. We will be later on.
Or you will install systems that someone else, that the owner can operate.
Oh yeah.
So what happens when two of those 200,000 a month drones fly into the same area?
If you have two systems on the same time?
Well, I'm suggesting that, I'm asking about how many drones you can identify at once.
We have seen 5 on the same time. That's all we have tested yet.
Yeah.
Probably more.
Yeah. Can you talk about the frequency sensitivity of your microphones in terms of what would be audible, 20 to 20,000 hertz beyond or below?
Yes, the entire scale, and we just use some algorithms to filter out everything that we don't want to hear. So it's a filtering job. It's part of the secret sauce.
Of course, but do you go below that or above that? I mean, I would think there'd be some very high frequency sounds that you.
No, it's mostly the sounds are 6 to 10,000 hertz. That's where we're seeing most of it. There are some over harmonics that we also try to identify because it's interesting, but that's a little bit of a more technical discussion. Yes, Marco in the back there.
You can detect up to the number you sort of claim now, but what do you do then? What is your concept of operations after detection?
We get our shotguns out. No. That varies a lot with the installation you're dealing with. The job we do is to have a risk assessment. If you're running an embassy within a city, obviously you cannot put a Gatling gun on top of your embassy and start shooting because that will probably scare the crap out of everybody around you. However, you can get your principals out of harm's way, and you can make sure that you know it's there, and you can report it, and you can do anything that you need to do with it. If you're guarding a person, you just need some head warning that something is coming up, and you can remove that person from the area of interest. There are numerous spoofing technologies that are tested and that we do know works. I don't want to go into that on open mic, but it's fairly easy to fool a DJI fan. Yeah.
What kind of nominal ranges do you get before you get too much signal attenuation in the atmosphere? How far away can you see?
Yeah, I'm not going to do that, not Mike, but there is a fairly good range on these things. And it depends a little bit on the ambient noise, because the more ambient noise, the less range. But we have, let's just say that we are beyond visual range.
Thanks.
All right? Yeah.
I think your topic is specifically, is very relevant right now. In the last week, we've been hearing about this drone that landed on the property of the White House. And the security people say that it just got in under the radar, as it were.
Yeah, you actually had a much newer story about a prime minister that is currently visiting Silicon Valley right now. There was some guy in Japan that loaded a DJFM with cesium water, radioactive basically, and landed on top of the Japanese White House basically, which I can imagine created somewhat of a stir. At least the pictures tell the story of that. So yeah, there are some stories out there that put some emphasis in this. Yeah.
Any false alarms from birds?
Yeah, not from what I know, because birds, they don't have rotating wings. They have flapping wings, and they have a completely different frequency. But if you're using radar or laser, you will certainly get some false positives. Yeah.
There are birds, drones too, actually flapping wing military flying the buildings.
Yeah. I've seen them. I don't see them as a threat quite yet, but they kind of obviously cool. Yeah, I agree.
All right, we're gonna have to, we gotta keep the program.
No, we don't. We can't take the next questions.
Take this off. Now, that's some really relevant, timely stuff, but we also have to, what else landed on the White House lawn just recently? A gyrocopter. And, if you can't see that coming, I don't think you're going to see the drone coming, but I think that was some good, we definitely had some good things to think about. Immediately, I think that can you talk about some solutions, spotting them and getting your VIPs or whatever out of the harm's way. When you start breaking out the guns, things get a little wild. But anyway, on to our next speaker, is VJ from Eagle, and he's going to come up here and tell us about, talk to us a little about LiDAR. Welcome, VJ.
Good morning, everyone. Today our presentation will be on the use of UAVs for gathering spatial information. So Regal develops and manufactures LiDAR systems as complete solutions for a range of market segments. They include the terrestrial, airborne, mobile, unmanned, and industrial segments. Today I'll focus on the two of our main products in our unmanned segment. That is the Rycopter and VUXIS. The VUXIS includes our flagship unmanned sensor, and the VUX and the Rycopter is the unmanned platform that we developed for use with VUXIS. UAVs are undoubtedly an effective new tool for changing the landscape of aerial surveying and data acquisition. It's important to point out that it doesn't eliminate the need for traditional aerial surveying. UAVs will help expand into areas previously not surveyed and allow for much more frequent surveys. UAVs are cost-effective form factor and ease of mobility. The scale of UAVs makes maintenance a much more cost-effective endeavor, which includes the cost of keeping the aircraft in the air. Now, the safety components of UAV is something that's frequently overlooked. Surveying aircraft sometimes have to get real close to power lines and surveying areas that present bad conditions that can compromise the aircraft or the crew. Now, moving on to some benefits of LiDAR integrated UAVs. There are a lot of benefits to this, and from a business standpoint, you have to be able to justify the technology by the operation costs versus the project costs. LiDAR-mounted UAVs will greatly reduce the operational costs in all aspects of survey-grade data as compared to traditional airborne surveying with pilot. UAVs allow for data acquisition at a fraction of the cost of traditional aerial surveying. Now, the result is a small form factor, which results in easy mobilization and deployment of the UAV, and lower operating costs, which results in faster return on investments. Now, a bit on the advantages of eco-digitization and waveform analysis. LiDAR and surveying are based on the same measurement concepts with precise measurement tools. Surveying measurements can be derived from a single LiDAR scan. Now, the way it is recorded is the way the data is, and there's no correction that needs to be applied. So a little explanation of the laser pulse with this target. So we have a pulse that's emitted, and we get our first return. The pulse travels out and reflects off everything and allows us to receive the reflection echoes. We listen the entire time, creating a baseline, and we have another return, which is expressed as a peak in the signal. So we can conclude that return when the signal goes back to our baseline. Now, the fact that we can record everything here is very powerful for the end user because the data can be used to deduce analytics on each return. So when processing the data, we have our multiple echoes, and we can see that the first echo is the top of the trees, and the last echo is pretty much the ground floor. Moving on to the Rycopter with the VUXIS and its components over the next few slides. The Rycopter is the first unmanned aircraft system developed and manufactured by a leading provider of laser scanners and systems. The Rycopter is an octocopter set up in a coaxial design for redundancy and efficiency. It allows for a LiDAR payload capability of 16 kilos, which is just around 25 pounds, and an all weight of under 25 kilos, which is just about 55 pounds, with half-an-hour flight times. The key component of the VUXIS is the RecoView X1 sensor, coupled with the IMU and GNSS receiver, and an optional RGB camera. The frame is built with weight reduction and efficiency in mind. It's comprised of carbon fiber and titanium with foldable carrier arms and shock absorbing undercarriage. The Rycopter offers outstanding stability. The payload capability and the dimensions of the octocopter keep it agile for controlled and precise maneuvers with all of the sensors during flight. Now this shows the Rycopter at an operation height of about 150 meters in Vienna in a precision agricultural case study. The portability of the carbon fiber mainframe that you see here, we folded the carrier arms and the shock absorbing undercarriage is ideal for all of your projects. Now some key facts on the Rycopter. With the VUXIS, you have a robust and reliable sensor platform. We've integrated the mechanical and electrical parts of the sensor systems to make it a complete turnkey solution. The dimensions when the arms are folded are approximately 2.5 feet by 3 feet. Typically, the height remains the same at 1.6 feet, and when it is extended and ready to fly, you're looking at approximately 6 foot by 6 foot. The VUX1 weighs approximately 3.6 kilograms, has a minimum range of 3 meters, and a maximum effective range of 350 meters. It's capable of delivering a 330-degree field of view on many platforms, but when mounted to the Rycopter, it's capable of a 230-degree field of view because of the airframe width of the stable Rycopter. Now some key facts of the VUXIS with a 230-degree field of view. We're able to attain 350,000 measurements per second with a range accuracy of around 10 to 15 millimeters. The VUXIS is a multi-sensor platform, so the first part of the platform is the RecoView X1 sensor. Then we have our first part of the INS, which is the IMU. Then the second part is the GPS data logger. And then the final part of it is your optional RGB camera, up to which 4 can be included on the system. Now, there are 2 ways to set up data acquisition with the VUXIS and Rycopter, either by remotely controlling it via the receiver and transmitter. This is where you can store the data directly onto the VUXIS. Now, Rico excels in time-of-flight-based systems and digital signal processing of the return waveform. The scanner has different measurement programs, which are 50 kilohertz, 100, 200, 300, 380, and 550 kilohertz. At a measurement program speed of 550 kilohertz, aircraft speed of 30 knots, and an altitude of 100 meters above ground level, The scanner can achieve a point density of 57 points per square meter with an even distribution. The VRX1 is the smallest scanner that Ricoh has built to date. It also has integrated internal storage and immense IMU, but for survey-grade accuracy, we integrate with other IMU GNSS manufacturers for survey-grade accuracy. At only 60 watts to operate the VRX1 means you can apply the power to staying up in the air for longer periods of time. Now, the VRX1 has mounting points all over the outer shell, which allows for easy mounting onto whatever aircraft is available for surveying. Now, here we have some alternative platform examples of UAVs. The first, we have a helicopter, which is a company in China called GeoInfo that's integrated the first VRX assist. Then we have Aeroscout on their UAV out of Switzerland, and Near Earth Autonomy, which debuted this system at AUVSI last year. Moving on to the Ricoh software suite. Ricoh provides a complete software solution that allows you to acquire and process the data to a completely geo-reference point cloud. So our software suite is optimized for ease of use, allowing for the user to achieve a one-to-one data acquisition to processing ratio, which means if it takes you an hour to acquire the data, then it will take you approximately an hour to process the data to a fully geo-reference point cloud to export it into your LES files or whatever files you desire. Our software is optimized for ease of use, allowing the user to achieve that one-to-one ratio. This is a turnkey hardware solution with the software suite to keep the user productive. So now we have some applications of LiDAR integrated UAVs. A few that I'm going to point out in some case studies are power line mapping, asset management, precision agriculture, and forestry. So this is an example of a precision agriculture case on the right-hand side and a forestry application on the left-hand side. The data was acquired, and from that data, we can create different models and layers as needed. The precision agriculture case that was performed shows us the differences in the mean height of the vegetation, and from that, we can see that there are holes in the dirt. So typically, there's some high points and then some low points within the data. For precision agriculture, the frequency of collects is perfectly suited for UAV applications, which allows for growth monitoring with observations, irregularities in plant growth to perform yield estimations. We can use data to also analyze terrain changes and observe soil nutrient conditions for long-term studies on geological change and growth characteristics. And for applications in forestry, we can define terrain models, ground conditions, vegetation, shrub layer, and deadfall, and also growth modeling. The next example I have is of a power line inspection and also open pit mining. So for power lines, you can see that we have our mission point cloud, then we can have our features, and then we can actually go ahead and remove the first point from the vegetation and just use the last point to see the ground floor and the power lines and transmission towers. We can acquire the complex features of the power lines and towers with no shadowing while also covering all aspects of the lines. The VUX would be ideal for this application due to the risk that operators personnel face when using traditional aerial surveying and getting closer to the power lines. So with the use of our sensor in an unmanned vehicle, we can mitigate that risk. The second example is of topography and open pit mining. So with that, we would use a terrestrial scanner normally, but utilizing the VX1 in an unmanned application, we can fly the area of interest, create our models, and then go ahead and extract the features for volumetric analysis. This is a study that was performed recently as a test pilot of the conservation area along the Pelac River. We were after measurements of the steep bank and slope over time. At first, we like to do a test flight to survey the area to be scanned with a Rye minicopter, as we call it, which is a smaller version of the Rycopter without the VRX sensor. Here we have some images of the typical test plan of the study area. So the first image, you can see that after the Rycopter has been easily transported, the arms are rolled out, and we're ready to begin our safety check. Next, we have a complete safety check being done before and after. Next, we have a data acquisition plan being loaded. We can also check the sensors. We also would like to check the sensors to make sure everything is completely working. After that's done and the flight plan has been approved, we move on to go ahead and set it up for flight. Here I have one of my colleagues in Austria setting or flying the Rycopter with VUXs with the FPV glasses. And then finally, an image of the Rycopter taking data in the Pelac River. So this shows a flight plan. That's typically what we use to cover the area, which is developed and set up for flight. It's important to note that this is a fully autonomous waypoint navigation system with ground station components. Return to home and failsafe is also built into the dual flight control setup on the right copter. And here's a screenshot of a 3D point cloud overview of the entire flight block that was flown over this section of the river. You can see the river is pointed out right here. The data is processed via the Regal Rival Process software. Here we have a DSM model with some shaded detail of the Peli River. Now a screenshot based on reflectance with the point density at its highest, measuring over 1,600 points per square meter, and at its lowest, typically around 200 points per square meter. Now using colorized reflectance here, we went ahead and just took a cross-section of the forest. And here I zoom in to show the detail of the branches that we captured via the Ricopter. And the lower blue intensity values that you see here, those intensity values are actually the foliage, and the darker intensity values is obviously the higher intensity values that we captured, and that's the bark of the trees. Finally, we have a 3D point cloud that provides us the detail via colorized reflectance of the steep bank and floodplain measurements that we're after. In conclusion, Regal is bridging the gap by combining all aspects of surveying between airborne, mobile, terrestrial, and unmanned LiDAR solutions. Our unmanned laser segment systems brings professional survey-grade LiDAR to UAVs, allowing for a wealth of new applications with its turnkey solutions. Now, we don't feel like there should be a competition in regards to programmable versus LiDAR. You're able to get certain analytics from programmable that you don't get from LiDAR and vice versa. So they should be complementary in nature, and you should be using both at the same time. Thank you all for your time. Any questions?
What was your maximum distance to target range?
Maximum distance is 350 meters.
Is this only available as turnkey?
No, you can purchase the sensor, the ViewX1 sensor itself, and add your own IMU. We also have IMU options available as well. If you want the turnkey solution, that is what the ViewX is, and it's also available separately.
You had an illustration of the application to a forestry project,
Right.
and you showed several different analyses, I believe. In the upper right-hand, left-hand corner of those, there was what appeared to be a very black illustration, which I thought, I assumed was the raw data. Is that correct?
Correct, that is the raw data.
And so it was a filtration of that data there we are.
Correct.
The other 5 are in fact various analysis results. Is that correct? You've either filtered them or however you process the data.
Correct. We process the data so we can get high intensity values, reflectance values, depending on which you can also colorize the data with the RGB camera that's on board to give you a true color point cloud of the actual scene that you're capturing.
Right. Okay, and then you have ground conditions. That's a totally a superficial measurement there.
Correct. So with the ground conditions, we just remove the first return, the second return, and we just use the last return, which is ground.
Okay, thank you.
Yep.
What are the safety considerations?
Safety considerations
Producing this?
in respect to
I
it is a class 1 isolated laser, so it's an invisible beam. Doesn't have any issues with, let's say, using some other systems you might have, the green lasers and red lasers would be using class 1 isolated. Thank you.
All right, we're gonna take a little break. Let's just do 15 minutes and reconvene at, let's try and get back here at 1:15. See if we can catch that time. Catch up a little bit. I'd like to be able to. You know, I'm on our slide share. Video slide share. And the videotape all this thing. Like to be here. Take your trash with you. Go ahead.
Just breaking down. That's okay.
What happened to Panasonic? You beat you out of there. Maybe he's doing something. We'll talk next week. I mean, he committed to it. I don't. I appreciate it. And I'm just glad that you. Well, I told you, you asked me. I told you.
Don't know. I can't promise.
Oh,
Motorsports, yes. Anyway, listen, I can't thank you enough for the opportunity. And, I'll tell everybody that you be here next year.
Transition to the future. Because it's
It's a color scheme I can't.
You're wearing the San Francisco Dodge color right here.
Yeah, we've made our whole company color scheme with that black color. Yeah.
All right, we're gonna keep rolling. Our next speaker. And we have Mr. Mark Kornblatt from Game of Drones, and he's going to talk to us a little bit about what these guys are doing. Also, Eli came and spoke at the first expo about Game of Drones, and people were like, what are these guys talking about? Game of Drones. What are they going to do? This doesn't make any sense. I go, hey, they're actually making something kind of fun and positive out of drones. And I thought it was kind of like a good idea, because if you can bring it out of, let's say, out of the shadows, and it's a family fun type of thing, and something you can do with the kids, then automatically it kind of takes that, let's say, dangerous edge off of it. And I think you guys have been pretty successful in doing that. So please welcome Mark Kornblatt.
Thanks, Patrick. As Patrick said, my name is Mark Kornblatt. I'm the co-founder and CEO of Game of Drones. And we are the drone sports company. Now, when you think about drones and sports, you probably are thinking about DJIs carrying GoPros, recording the actions of people playing sports. And that's not really what we're about. We don't build camera platforms to record athletes. We're actually creating a sports league and a sports environment where the drone flyers are the athletes. We started because a few years ago, some robot builders, friends of ours, we would meet on Friday night and have an informal fight club. We were fighting our robots and our other inventions together. And a few years ago, we started fighting our drones. Back then, most of the drones that we had available to us were commercially available over the counter. And we immediately realized that they were not up to the task of fighting, crashing, smashing repeatedly. In fact, most drones are quite fragile, and for a very good reason, they're designed around the concept of keep it in the air, don't crash into people or other things. With Game of Drones, we actually took the opposite approach. We said, let's smash our drones together, let's crash it, and really find out what the durability of the drone can be. And immediately we realized that there was a great need for not only drones that could be repaired quickly, but very inexpensive. So in addition to drone fighting, we also got involved in drone racing. And if anyone here is yet familiar with this new pastime that's emerging, drone racing, it's basically done through FPV with an onboard video camera transmitting wirelessly back to the operator, who is relying solely on either goggles or a small monitor for the flight. So it's as if that pilot is in the cockpit of the drone. And I could go on and talk about the fast rise of the groups and clubs all over the country and the world who are into this FPV racing, and talk about those stats, but I know none of you are listening to me right now because you're transplants. And I think that's actually part of the key about why Game of Drones is somewhat successful, is because we're tapping into this very thrilling, exciting, visceral experience of this first-person FPV racing that puts you right in the cockpit and gives you a flow state experience unlike any other that you can get while flying a drone. So that's the promise of drones, is the the excitement of racing, the thrill of combat, the camaraderie. I have a little, this is supposed to be a slightly different video here, but we'll let this run for the moment. But basically what I was going to show in this slide was the durability of the drone became a real proving point for my partner and I. And long before we were in business, we were just trying to make these drones. We were making viral videos and sharing them online. And a lot of people out there said, hey, I love how you did your DIY, but we don't want to do it ourselves. We would just sell it to us. And so we decided to do a Kickstarter to sell this airframe, this indestructible airframe that I have a version of here. And what is going on here? And truly, the idea that these drones are somewhat indestructible. And even if something did snap or break, the idea that you could repair it in under a minute or so with virtually no tools, that became a kind of rallying point for us. This is probably not good. Let's see. I may need a little help getting this back into place here. This isn't mine. Let's see. Maybe Patrick or some other technical person can help me get this back to it. I'll continue what I was saying here. So it became a real rallying point for us to make these indestructible drones. We were sharing the videos online, and they became kind of viral. We've had a few videos that have over 1 million hits. One of the ones that was most well received, as well as negatively received, was one in which we were testing our drone by doing all the typical tests, dropping it, crashing it, and we did a final test of shooting it with a shotgun. We were using a bird shot of it, and this airframe that we designed was actually able to withstand those shots from a shotgun. It would get knocked out of the sky and hit the ground, but in some cases, all we needed to do was bend the prop back and we'd be back in the air. We might have needed to replace a prop or two if that got shot off by the shotgun, but the idea that the airframe and the components that were protected inside of it withstood all of that. And so from that, we did this Kickstarter that I mentioned. And we thought we were just going to do a Kickstarter to kind of quiet our fans who were demanding that we sell it to them. Maybe we would make enough money to get a 3D printer and some other tools, and then we would just kind of move on. But the Kickstarter was so successful, we got so much attention for what we were doing. There was so much, there we go, okay. So we ended up getting a lot of really positive attention for what we were doing. And people realized that not only were we kind of putting drones into this kind of violent game, pitting them against each other, we weren't really advocating drone violence, we were actually advocating drone education and community. And so that story came through the media really well because they're all looking for these sort of negative drone stories about how they're tools in war and tools for spying. And our story was really quite different. We were saying how drones can be used for fun, that consumers can use drones for fun and games that are family-friendly, educational, and in fact the community around this concept has grown up so quickly and so vehemently that now we have launched what we call the ASL, the Aerial Sports League, so that we can have legitimate league-style events that happen not only here in the Bay Area with our local community, but all over the world with these other groups that are starting and looking for leadership as to how to go about setting up these racetracks, how to do it safely, how to get their local flyers and local communities involved. And these are just a couple of pictures of some of our recent events. The one in the lower right-hand corner was actually our first public event at Maker Faire last year. And in just a few weeks, we'll be visiting Maker Faire again, focused on the drone combat. And it was so successful there that it's become one of the major draws. And now our setup at Maker Faire, it's almost like a boxing ring, where there's a 20 by 30 foot combat arena surrounded by a net in the middle, and it's surrounded by bleachers. And when we do our show, and when we have this thing going, we're surrounded by literally 5,000 to 10,000 people, all cheering on the drone pilots. Not only cheering them on during the fighting, but when one of the drones hits the ground and needs an emergency repair, under the countdown clock, the audience is enthralled by that. We thought that was going to be dead time, the engineering in between the fighting and the flying. As it turns out, the audience loves to watch these pilots and their teams frantically working on these drones, pulling zip ties off, replacing motors, batteries, all kinds of stuff. We've seen pilots actually essentially tear down and rebuild a drone from scratch in under 90 seconds in the combat arena. And so that creates not only an interest in the thrill of combat and the thrill of the games, but it drives a real interest in the engineering, the software programming, hands-on working with tools, teamwork, working under pressure. So in the end, while we're sort of tricking them into thinking that they're doing this naughty thing in drone combat, in reality, we're sort of warming them up to the idea that drones are tools that are here to stay. And by participating in our events, we're actually creating better engineers and, more importantly, better and more responsible pilots. We see the future of drone sports following the current trajectory of video game sports. I'm not sure if the people in this audience are quite aware of how internationally popular video game sports has become. This picture here, I believe, is from a tournament in South Korea in this past year. And you can see the stands are filled with people there just watching teams play video games. The potential to stream this content live online to watch at your leisure has proven so popular. Twitch TV was recently sold for, I believe, $1 billion to Amazon after only a few years of business. So we see the future of drone sports mimicking the future of video game sports and really giving traditional sports a run for their money. And ultimately, I think the reason why is expressed here. It's fun, it's educational, it brings families together, it lets you get down and dirty, but do it in a way that's completely safe and sane. And in the end, you're actually learning something, and if you're a pilot, by participating in this event, you'll actually become a better pilot and conceivably actually have a career path that comes out of this as drones become more viable as a vertical market for employment. Once again, my name is Mark Corlett. We are Game of Drones and the Aerial Sports League, and we are the Drone Sports League. Thank you. If anyone wants to take a smack at this, go for it.
Mark, do I understand correctly that that picture from Korea is an arena full of people watching one of these things?
It is. If I'm not mistaken, I wish I had the exact numbers, but internationally, the size of the audience for video game sports eclipses the size of the audience for things like NASCAR, the NFL, and all what we consider American sports, all combined together are dwarfed by the size of esports or video game sports. And most of the people...
Do video games do more revenue than movies do?
In fact, video games in general are by far the most profitable entertainment division, far eclipsing movies and television and theme parks and things like that. Video games, if I'm not mistaken, the recent release of one of the Call of Duty games was the single biggest income generator for any entertainment property anywhere in the world. Something like $1.5 billion was earned in the first day that that game was released. These numbers and those sorts of figures are becoming more commonplace in the world of video games. Video games have been around for decades. Drones, in terms of consumer awareness, have only really been around for a couple of years, and we're already seeing a trajectory for the future of video games and consumer entertainment, or drones and consumer entertainment, eclipsing what we now think of as what's available in games.
All right, thank you, sir. Look forward to.
Oh, and if I may, one more point.
Yeah.
Maker Faire this year is May 15th, 16th, and 17th, so that's just a couple of weeks away. And if anyone is interested in going, please contact me after this, and I'll get you the invites and the links that you can go. It'll be by far probably the largest drone combat gaming event that's ever occurred in the world. So if you want to see what that's all about, it'll be in just a few weeks.
And yeah, and I'll probably make that. I was at one of your events a couple weeks ago. It was a lot of fun, a lot of families, kids. Then you guys did the LPV racing, they did the cage fighting, and some freestyle stuff. It was pretty fun. It's worth going on to check out. Thanks, Mike.
Thank you.
Okay. Our next speaker is going to talk to us here about some thermal, your thermal, right?
Yeah.
Thermal imaging. It's Claudia. I'm not going to ask you your last name, so come on up here and introduce yourself. Okay, come on up here, get started. Yeah, you can do this. Or you can do that. Sure.
Hi to everybody, I'm Claudia Spinato from Italy. My company Panoptes produces the multi-sensor on which I wish to talk with you. It can be used for technical inspections by OLB, especially for that one in which is needed to search for difference in temperature, such as in inspections of solar farms, where the elements which are overheated are elements which does not work well, and so the thermal flight is useful to check them in a preventive way, to give details to the maintainers for giving that sequence work directly in the ground. But the problem, there is a bad presentation. Okay, I don't go over it. The traditional inspections with drones are done with an UAV, with a thermal camera, with sometimes with also a view in the physical eye to see the different doubts such as dust or cracks on cells. And it's better to have a binocular vision, having them both eyes together, and to have a live viewing during the inspection to see the thermal video while you flight, to see criticalities when you flight. And then it's important to record on board. But these kind of traditional inspections are not really useful because the problem is that the PV plants are big monotonous landscape, and thus if we only take videos from above, we have to fly at a relative quantum of about 20 meters to have right thermal data for spotting cells. And so we evidence in each frame only modules and always modules. And so you see the real problem, because in post-processing we need a lot of time to process the data. And this time is so much that the benefits of the aerial survey is lost. And so what we have thought is that the UAV operator needs a system which is not only traditional but also help in surveying and in post-processing till doing the final report of the inspection, to help him to go faster with the survey, because the important thing is that the UAV operator has to fly, but he can't have a full knowledge about each field of application. So in our opinion, the system could give him an help in having a knowledge about the domain. And so we have put in our system also the location aware, so the user can have directly the location of the criticalities of the map. And so the system is composed not only by the real thermal camera and HD video camera, such traditional systems, but it also allows to record videos on board. And inside there is a GIS, that is the GeoEarth of the system, which allows to locate directly the criticalities over the map. And this is the print screen while you are flight. When you fly in the field, you see the thermal video in real time. You see that black dot is the position of the drone moving on the map. The square is the blueprint, and you can see everything about what the drone sees. And when you see criticalities, you can bookmark it. And for the second post-processing at home, at office. The system is specific for small drones because it's lightweight, it has visible and thermal sensors, it records on board, has live video transmission, long battery, and is spatially enabled to produce in automatic mode the final report of the survey with the map of criticalities. The key feature of the system are that it's a plug-and-play system. And so you put it on the drone, specifically designed for drone and universal. You can use it for any kind of multi-rotor, and you can use it at once. With the GeoEarth, as I thought first, for live viewing, for pressing criticalities on the map, and you can start to survey very fast because it's easy to use, and we give an initial training of about 6 hours to an expert pilot of UAV, and you can go survey early. At the end of the inspection, the system automatically produces the survey report with the map of survey and the map, the PV plant map with criticalities and data sheet of each one of them. And so this map is not important to stitch the thermal data for this kind of inspection. What is needed by the maintainer is the plant of the solar farm with the criticalities over them to go to check the panels which are overheated by ground. And so, criticalities are evidenced by visual, but it's very easy because if you are module oriented, they are clearer in the thermal frames. And so you can check them visually in a very easy way. I want to show you how it works. Advantage, I told them first, I'm sorry, but this presentation is a long one. I give the shortest to Patrick, but he forgets to put it on the computer. So I already told about this. I want to show you the system working. Okay. The standard workflow of the inspections has some steps which you must do only one time: the operation assessment and the preparation, the referencing the map, and planning the flight. You have to do it only one time, and then you can proceed with survey and post-processing every time you wish, very fast. The result is that you can survey on half a megawatt in 7 minutes and have the final report in about an hour. That is, this kind of job is done by ground in about 1 day for survey, another 1 day for reporting. And so the difference is very strong. I wish to show you what's happened during the flight. You see the drone moving, that is the black dot with the footprint. On the right you see the thermal video in real time. And if you have to see a criticalities, you can bookmark the video with a pushing button. And so the system bookmark it for later, for post-processing. Later, at the office, you repeat the visual of the play of the thermal video in high resolution this time. And when you see criticalities, you push the button annotate. You stop there. The system bookmark it, but you can annotate with graphical and textual notes that frame, and the system put it back later and put in the GIS level of the panels all the data you have inserted to use it later in the GIS. More later, you can also check the route, so you can see you can check if you have covered all the routes you have decided in the flight plan. And finally, when you have finished with the visual inspection, you only have to give to the system your data, which company, which pilots, and so on. And the system produces directly the final report of the inspection with the map of criticalities, with the route map, your reader and map of criticalities and data sheet for each one of them. And this map is what the maintainer needs to go faster with the ground checks. Thank you for attention and sorry for the confusion with the long presentation. If you wish to see the product, it is exhibited in the room, in the near room.
All right, we're a little ahead of schedule, which is good. It's always good. Thank you, Claudia. Our next presenter he's a relative newcomer to dog chasing. How long have you been in business, Dave?
Business since 2007, and doing unmanned systems since 96.
So he's been around a little while. You've probably seen his products out there in the world. You guys definitely have had a quality product that's been out there for some time now. And every time I talk to people, they say, oh, we talk about the different systems. Your system usually is one of the systems that gets mentioned. So, Dave, you can come up here and you can talk a little bit about what you're doing. Thank you, sir.
All right, fantastic. So what I'm going to talk to you about today is some of the civilian applications, specifically infrastructure inspection, that our products are being used for today. So I'll run through a little bit of corporate background to tell you who we are and what we do and where our products are being used. And then get into the specific application, which today we talk about power line inspection. What are the challenges of it? What are the benefits of using unmanned systems for this application? And then some infield examples of how our products are being used for that today. So Aerial Labs builds rugged, easy to use unmanned systems for the backpack of the soldier, the trunk of the police car, the pickup truck of the power line inspector, and this week we've got a team actually in Nepal doing aid work. So really this field deployable rapid response system. As Patrick mentioned, the company has been around for a while. We were founded in 2007. Our first product, the Aerion Scout, was introduced in 2009. We really built the product with ease of use in mind, and actually designed it for the commercial civilian market. In 2013, we succeeded that product with the Aerion Skyranger, and earlier this year announced the HD Zoom 30 payload, which I'll talk to you about. It's the application that's focused on and being used for today is this infrastructure inspection. We have customers all over the world, 30-something countries. We work in military, public safety, and commercial applications. We've had the pleasure and the benefit of being involved in some pretty big world events, and we work. You may be familiar with, for example, the mapping of the Chrysler Redeemer statue, which we did with folks from X4D. We were first used by BP during the Gulf oil spill. So as Patrick said, we've been around for a while. So our philosophy is building easy to use things you can fly anywhere, anytime. If you're doing this urgent response, bad things don't happen just on bright, sunny, calm days with no wind. They happen when it's raining, they happen at high altitude, they happen when it's hot, cold, whatever the case may be. And we built the system from the bottom up. So there's the system component, and then there's the user. For us, we don't focus on drone operators, who would be the operator of our system. We focus on a power line inspector or a police officer who is doing his core job first and drone pilot second. And really, if at any point our pilot is paying more attention or more distracted by the thing that's in the air than getting his job done, that's when we fail. So let's see if I can get the video here. So the system is packed and deployed out of a small case or a backpack, and is designed for those kinds of operations that I've specified. A single operator, so you don't have to have a camera operator and a payload operator. That happens all automatically. And many of our missions are actually conducted almost fully autonomously. You can draw a box on a map, and the system will automatically go and collect the imagery. We do quite a bit of work outside North America, so we're not always restricted by line of sight operations, and so we do work up to 10 kilometers actually away from the operator. And we have the highest capability environmentally with our product in vehicles in our class. So we can operate in winds gusting to 90 kilometers an hour, 55 miles per hour, and a class-leading endurance of over 50 minutes of flying time. With the imagery that we gather in those harsh environments, we're able to do sub-millimeter inspections, as you'll see shortly. So that's a little bit about the bird, and on the operator side, it comes down to this user interface. What's in the pilot's hands? How does he get his intel right now, and how does he focus on getting his job done? So we stripped it down to a two-dimensional interface. Basically, you can't go up, down, and left and right at the same time. A lot of our operators can't think in 3D, so we actually kept it as a sort of 2.5 dimensional display. To operate the system, you can see my mouse here. You'd simply say draw a box in this area if you wanted to map that area. If you need to conduct an inspection, say over here, you click in this area, the vehicle would travel there. The entire time you've got real-time digital video displayed in the operator's hands, and that can be sent to other local devices and multicast. It's entirely digital and IP focused. So now I'll tell you a little bit about the application that we're going to get into today. Power line inspection. So power line inspection is actually a very challenging task. The goals of power line inspection usually are threefold. Number one, inspect the tower structure, where you're looking for cracks, deterioration, rust, other signs of wear. Reading serial numbers, lot codes, date stamps. When was this tower built? A lot of the infrastructure has been there historically. They may not have that data readily available. Second is inspecting the insulators. This is one of the main points of where broken insulators, sometimes they're coated with a coating and they're looking for a breakdown in that coating, or they're contaminated. This can result in loss of electrical energy through these insulators, as well as can result in, ultimately, it could take down this portion of the power grid. So that's one of the places they're looking for problems. And the next is inspecting the fastening hardware. So whether that's been done properly at the onset, or whether a cotter pin has rusted and fallen out and is no longer in place. And to do this requires very high levels of detailed inspection. So you need to literally be counting the exposed number of threads on a bolt, or reading a very small serial number. Sounds like a great application for you. Traditionally, this is being done either from the ground with telescopes, or sending people climbing this infrastructure. As you can imagine, power lines have to cross rivers, they have to go over mountains, they're not always just sort of on the side of the street, so they can be in very difficult to access areas, as well as the fact that most of what you see is up top, and when these are energized lines, can sometimes be hundreds of thousands of volts, and that's a dangerous place to put a person. The cost of failure is extraordinary, so there's a lot of preventative maintenance work as opposed to reactive work that needs to be done. They do some of this with manned helicopters. I'm sure you've probably seen it over the years, where they'll actually fly out in the middle of the desert and drop people on energized lines to do work. It's incredibly expensive, dangerous, and you can really be limited by your ability to get close to these things. So whether that's in the middle of the water somewhere, middle of across a river, or at the top of a mountain. The other challenge that's presented when you have energized lines and you're operating, I mean, you can essentially generate small amounts of what's called flashover. If you put conductive structures near these high potential electrical, there's magnetic interference problems. Anywhere you've got electricity flowing through lines, you have magnetic interference, as well as there's often obstacles. Those could be trees, those could be just the power lines themselves. So it's a really difficult place to put put a UAV, or first of all, it's a difficult place to put a person, and then it's an even more difficult place to put a UAV sometimes. So what's this? How do we take this and apply UAVs? So you can do this what we feel is the hard way, and that's put a UAV right up there, centimeters, millimeters, inches from the thing you're trying to inspect. Lots of challenges with that. Any UAV is going to succumb to the wind. You will be blown around. You will have to deal with that. So you risk running into things. You need very, very precise positioning, skilled pilots, and a wide field of view, high-resolution imagery. Or what we believe is the right way to do this, which is maintain a reasonable standoff. And that's where what we've done is we've introduced this product, our HD Zoom 30. So the HD Zoom 30 is a 1080p capable, 20 megapixel, 30 times optical zoom imager that lets us work as narrow as, I think, 1.5 degree field of view, so very, very precise work, which allows the vehicle to stand off 20 to 50 meters from the target, sometimes a little bit closer depending on what you're trying to do, but it's a safe enough distance so you're not dealing with these challenges of flash up. With the ability to bring zoom, you can get that level of accuracy that you need by using the platform that's tightly integrated, and with the optimizations that we put into the system, you can stay on target longer. You can do multiple inspections of multiple power lines and towers from a single point base of operation. You can operate farther from the launch. This map-based interface that we use means you don't need to see the vehicle to fly. You don't need to know where left is, right is, up, down, left, right. You need to know on a map, here's the coordinates of my tower, go here, and since you're not operating in close proximity, you're less worried about collision with the infrastructure. And our platform is able to work in really any of the most challenging conditions, whether that's at altitude or in medium weather. So next I'd like to run through a couple scenarios, just to give you an idea that this is not what could be done in electrical inspection, this is what's being done in electrical inspection today. I suppose one of the things that I should also mention is that we're a Canadian company, and as a Canadian company, we've been flying under special flight operations certificates really since the company's inception. We have customers in the public safety space as well as in the commercial space that have been doing these operations today. So we actually have quite a bit of experience doing this today. So let me run through a scenario. This is an inspection of a 500 kilovolt power line. In this particular case, it's on the side of a hill. About 400 meters from the operator. Again, the challenge of parallax and understanding depth of field is a challenge when you're trying to operate close to a power line, and it's an energized line, so you can sort of see the takeoff location there at the bottom right. So the goal of this particular operation, again, this inspection, reading serial numbers and counting threads on bolts. So hopefully you'll be able to see this from back there. The size of these stamped letters is less than 1/4 of an inch in height. And in this particular case, we're about 7 meters, 21 feet, 25 feet, something like that, of standoff distance. So you're at a safe standoff distance where you're not worried electrically, and you're able to, and this is really stamped letters, so it's a low contrast, number that you're able to detect with the product. The other example that I have here is trying to count threads on a bolt, and you're very clearly able to see and count the number of exposed threads on the bolt and the state of that cotter band. Another second example here, and I'll run through a few of these. 1,000 feet, 300 meters away from the operator. So it's important to have that, not only ability to travel that distance, but then a system that can handle whatever conditions may arise when you're that far from the operator and handle them itself. So at Aragon, we've designed a product that does does the flying so the operator doesn't have to. If you've got a low battery, the system is going to turn around and come home. If you've got a loss of communications, it's incredibly important that in a loss of comm scenario, especially when you're operating your critical infrastructure like this, you don't result in causing more of a problem by crashing into the infrastructure, shorting out the power lines. So that's where we build a lot of this safety. Show a few examples in the video here. We've got another one later as well. So this is at about another 7 meter standoff distance. This is the HD 1080p video that the system is able to collect. So you can actually switch from video to stills. These are, again, less than a 1/4 inch in height, serial numbers on insulators and stamps on the power infrastructure itself. To give you a little bit of an idea of sort of the standoff distance, you can see from this wide field of view the kind of overall perspective that you have on the tower, so you can tell that the system is a safe distance away from the tower. And you can see as we zoom in here from full at 1 time zoom all the way to this, I don't know if this is 30 or 60 times zoom, and then take a series of photos, you're actually able to conduct this infrastructure inspection from a safe distance. Just a couple of examples as well. Sort of sub-millimeter. In addition to visible light inspection, thermal camera inspection is another way to detect potential failure points in infrastructure. The SkyRanger has both a dual infrared and visible light payload, so you can actually tie together your thermal imagery and your heat map with your visible light. And what's really great is that this capability and this close-up, this high standoff close-up inspection is a common challenge in mirrored in other industries. So we see the same challenges, whether that be solar farms, wind power generation, chemical plants. And just as an example, or just for reference, all of these images are actually images gathered from our products, stock photos. This is that tower right there is actually just outside our office, and we're able to identify connections and cables on the tower. And as I mentioned, we've been doing this for real for quite a few years now. Multiple FAA 333 exemptions, both for oil and gas inspections, onshore, offshore, power line inspection, and plants inspection. And on if you're looking at on the governmental side, we're actually one of the first, or the first, to have statewide operational authorities, in this case with Michigan State Police. But that really mirrors itself in other industries where once you prove that out on the government side, those we'll probably see more of those codes coming. The other thing that's great for us being a Canadian company is our product's not ITAR. So we've been able to do this all over the world, and we hope to see more of this happening here in us. So with that, I'd like to close and open to any questions that you guys may have. Yeah.
Any problem with the electromagnetic fields of the power line that would have an impact on the compass or the GPS?
So that's absolutely one of the concerns, and that's where using a high optical zoom camera at a larger standoff, magnetic fields that fall at a rate of 1 over r cubed. So it's actually every inch matters. It's a factor, a cubic factor there. And so by standing off, at minimum is 5 to 7 to 10 to 20 meters, we're able to dodge that bullet entirely. Yeah.
Do your aircraft have flight data recorders and most work?
Absolutely. So the SkyRanger does everything you'd expect from a big UAV in a 5-pound package. So all of there's onboard flight data recorder as well as the telemetry is sent back down to the ground for post-analysis, be that in the case of an incident or just for fleet monitoring perspective. You can detect problems early by analyzing those flight logs before the. Question. Yep.
Did you say you changed your user interface based on what the job is you're trying to do?
Not yet. That's as we learn the specific things that are important for each application, we have the ability to turn on and off features for users. What we've done is we've kept that interface 2.5 dimensional, I think is probably the thing you're referring to. So as opposed to doing complicated 3D maps, which are challenging to plan from for an operator and difficult to get depending on where you are, we use basically a Google Maps-like interface and use that and allow the operator to pop it. I answer your question. Great. Yes?
You mentioned that Canada doesn't have LiDAR, but Canada does have export controls.
Correct. Canada is part of the Wassenaar arrangement. ITAR is a special thing that the US State Department adds on top of export restrictions. So we are governed by the same as the 40 signatory countries to the Wassenaar arrangement. We work closely with the Department of Foreign Affairs in Canada, and our product has actually been deemed non-export control. So we actually have a blanket export certificate that allows us to send our product anywhere in the world except for military or economically sanctioned countries. We made a lot of choices actually at the onset. As I mentioned at the beginning, we set out with the goal of bringing unmanned systems to the commercial market. So we chose COTS materials, even our thermal camera, for example. We use the 9 hertz version of the camera, which is not export controlled, as opposed to the 30 hertz ITAR version of the camera, so that we can sell them. That's what those sticky ones would also tell you. Answer any other questions?
Are you making, in addition to the mechanical stabilization, are you using also digital stabilization? So when you're zoomed in all the way, you can still see.
Yeah, so in the videos that we would have seen here, for example, no, they didn't. This is running mechanical stabilization on the platform. So the platform has a whole flight control or whole position stabilization. The gimbal is running for mechanical stabilization. In the optical path, there's optical lens stabilization. There's no post-digital stabilization on top of that. And this is the tech of this thing. Sorry, good question.
No, I think that kind of answers a lot of questions.
All right, great. Thank you very much.
All right, so that was a good one too. Okay, our next speaker, who's coming up here now, Brandon. That's his last name from Skycatch, and you have some fresh stuff from. Let's switch over here. Oh yeah, we have. Yeah, ready for you? Yeah. Okay, let's do it.
Yeah.
Oh, okay, good.
Good morning, everybody. How you doing? Good. So I'm hanging in there midday. So I wanted to introduce myself. My name is Brandon. I'm from Skycatch. Skycatch has an enterprise-level platform that we work with mostly construction, mining, and agriculture companies. Today, I'm actually going to talk to you about a subset of some of the features that we provide. So, consumer drones are really taking off. Just being here today is a huge evidence of that. Up on the screen here, I have quite a few drones inspired that just came out, an absolutely amazing consumer-level platform. You look at the Solo, we have the Iris Plus, Bebop. These tools have really brought the ability to have anybody out there become a pilot and a mapper. But there's a few things that need to happen to really support them in that effort. So Skycatch is really based around enterprise level mapping. And so what we wanted to do is create a system that we could basically outreach that back-end data processing to people out there in the world that currently have machines that are capable of doing that, but not necessarily the platform to support. So today I'm here to talk to you a little bit about work mode. So work mode is something that Skycatch created to really fit a certain niche of the market that we saw that was actually growing and growing quite rapidly. And the market is, let me just give you a very high level of what that market is. It's any piece of land that sees frequent change. Now, when we embarked on this work mode program, we didn't really understand all of the certain requests we would get. Requests from cemeteries to have the land maps. That's not something we ever really thought about. Waste management systems, coastal restoration projects, accident reconstruction. The work mode platform ended up opening up a whole world of necessity that's out there in the marketplace, and we wanted to create some tools that could get customers to that point and get them the information they need. So ultimately, I'm sure the question is begging, what is work mode? Work mode is really two things. We've created a marketplace. We wanted to have customers that needed maps to be able to link up to pilots that were capable of producing a map for them. And then secondly, pilots' jobs were going to be out in the field flying safely and understanding what needs needed to be met by the customer, not data processing. So we created a very easy, seamless end-to-end system for them to basically upload the imagery and have it processed. So with that being said, it really came down to a point of what we wanted to combine with what we've built, Skycatch as a company, and how it could extend that to anybody out there with consumer level drones. And actually we had this pretty funny article in Wired magazine, but they coined us the Uber for drones. If you needed a drone pilot and needed a map, you could basically make this request and it would show up on the site to fly. So to give you an idea, today we have over 200 maps that have been flown worldwide, a majority of them in North America here. One of my favorites, I don't know if you can see, but just off the coast of Africa and Madagascar is a tiny little island. And there's been over 10 flights that have been done. That was just something when we started on this program that really grasped how far, how expansive we've gone across the globe to basically provide maps to people that didn't even have the ability to do it. So it's quite complicated to build a map. I'm sure all of us here have some concept of the difficulties of getting a machine up in the air, understanding flight planning, and understanding what really needed to be inputted into the machine to collect the correct data to actually produce a high quality map. And so we wanted to make this process incredibly simple. So what we did is we provided an online interface for the customers to highlight the area that they needed to have flown, provide some very simple but necessary information about what the site requirements were. What exactly was this pilot going to be doing? And then what happens is this request gets fed into the work mode system. We actually have one of our certified pilots for the work mode fleet talk with a few of our pilots from SkyCatch. We go over mission planning and we have the site flown in the specified time frame that the customers need. And this is actually delivered right back into the same dashboard that they ordered the map. So this is actually a map. This was very interesting. I don't know how many locals we have here. Anybody local? Okay. So this actually is a map of the Milpitas Park Station. So this is the extension from basically North Bay all the way down to San Jose International Airport. The customer had basically an issue. They had multiple survey work done, and they couldn't actually find the ground truth for the area. And they had a specific requirement to get some imagery and get a map produced in a very short amount of time. And they said, what can you do? Can you do this for us? So we said, actually, I have a pilot that's probably 5 miles away from you. When do you need it flown? And they said, today. And we actually were able to get it done in that amount of time. Now, on this map, we show you a few more tools that are actually baked into our system. That kind of light blue hue you see is something that we've built in called automated change detection. Now this is basically based in computer vision. We compared day-over-day change on the site. So this actually was the third day that the site was flown. We had compared what had happened on site day over day so they knew the areas that the dirt had been moved and where they were falling behind. And we actually provided 3D volumetrics. If you look on the bottom left-hand corner, we actually had tagged the volumes of each of their stockpiles and provided a cubic volume for them to basically start understanding, is this project falling behind at this point? And they needed to know what stockpiles, how much dirt had been moved. And basically this series of maps, and there's 5 maps done, led to basically a recurring flight with this pilot, and now it's got the project almost back up to speed, not quite. But the amount of information they could get so quickly really blocked the way that they started processing this information and using it on the site. So the interesting thing is this really helps the drone in space on multiple levels. We have pilots now that can go through certification, that can start approaching customers and have the ability to provide a product to them on a much cheaper cost than the customer normally does and create a whole new industry. And I think that's pretty obvious today when you walk around and see all the quadcopters and fixed wings out there. And work mode really is designed to fit that niche of the industry as far as the data processing and making it easy of use for the customer. So lastly here, unfortunately the tragedy in Nepal, and I think this is a very interesting time that happened, especially when we're speaking about it now. Work mode actually has helped, so SkyCatch has already sent out a few dedicated pilots to help with the search and rescue efforts, but we actually reached out to a work mode community of certified pilots and asked if they'd be able to come and help us aid in the effort, in the search and rescue effort, as well as basically all the mapping that needs to get done as part of the reconstruction process. And today we've actually had 25 pilots from India, Thailand, Australia, and a few from the US that have actually come out and started to arrive in Nepal and start helping with the relief efforts. So I think this kind of also shows another aspect of the tool, this on-demand need to have a pilot force that can be used to do search and rescue during natural disasters. And this is actually the first time we've used it for this, and the response so far has been amazing. To see that we have 25 people basically within a week's time frame getting ready to head out to support these efforts is just nothing to amaze all of us. So I was very happy to talk to you about this today. This is the end of the show, but I'm sure we have a few questions. So at this point, I'd like to field any questions you guys may have in your mind. Way in the back, yes.
How do you deal with what is the model for liability and insurance issues in SkyCatch? Since they compare the two firms, so they might have similar problems the same.
Very good question. And yes, the issues are exactly the same. So we actually require all of the pilots to have insurance. We've worked with 3 different insurance providers to basically provide plans that are available to the pilots. And that's actually part of our certification process, is we make sure that they're insured to certain degrees. And then each pilot has $1 million, $2 million of general liability coverage, and the actual customer is able to specify what the insurance needs are for their site. Most general contractors have a certain dollar amount that they need, and that actually helps us while we go through the filtering process of finding the correct pilot for the site.
How do you recruit your pilots?
It's all organic right now, so events like this, but we actually do outreach. Today, we've actually already had 3,000 pilots in our system, and we've been certifying them as fast as we possibly can. That number is climbing incredibly quickly. And ultimately, we certify pilots based on need as well, for depending on where the areas that we have high need, like in Nepal right now. We've actually gone back into our database, looked into pilots who have submitted requests to become a working pilot in that region, and actually started working with them to get them up to speed, start training them so that they are able to go out and provide help to the effort. But that's a long process. We all know how long it takes to learn how to properly fly a machine, fly safely, design missions. So that's something that we work with our recruiting pilots on. That's what this one.
As regulations develop in the US, are you guys going to be changing your pilot guidelines to fit those that require them to meet FAA regulations or whatever?
Absolutely, and we can't wait. So right now, our certification process, give you a little background on that. So SkyCatch has multiple exemptions. We're the first to get one in the construction industry with Playco. We base all of our pilot certification on the exact same flight planning, mission planning, and operational parameters that we have in our existing exemptions, because really it's the closest thing that we can do right now. So what we do is the pilots actually go through 3 phases of certification. First stage is they actually go through an online training course, and they have to go through a test. And then secondly, they actually have to fly a mission and provide us with a map, and we will basically understand if they have the right equipment and the right understanding of what needs to be done. And then we'll work with them if they need work. But truthfully, most pilots, as you can see, there's many drone companies out there today that are using this. And the majority of our working with pilots right now actually are companies that already are using drones for their main job, and they're just actually accessing the marketplace to try to find new different verticals that they can start doing that. So that's kind of the start around the question. And I think you had a question?
Same question.
Oh, was it? Okay. 2 birds, 1 stone.
I have one other question. Do you guys notice that your pilots are using you guys to get clients and then backfill into the clients directly?
So they can absolutely do that. Our goal here isn't to, if you really look at the genesis, what we want to do is provide the data processing for the pilots. The marketplace is kind of secondary to that. Ultimately, pilots are going to be out there, as in all of us know, making money by spending time in the field flying, not processing. So the way we've really structured our platform is that, look, your job is to be able to go out and fly the sites. All we need is geotagged imagery. That's the only requirement. It gets uploaded into Box and then fed into our data processing system. So unless they want to, if a customer basically says, hey, look, we only want to use your marketplace, we'll take care of all of our processing. We already have, a picture and Antisoft and Recap, whatever they want to use. then they have the ability to do so. Yes, sir.
Are you pilots, licensed pilots?
So we do have different variants. So we do have certain pilots with scored pilot's license all the way up to private pilot's license. We also have some pilots that don't have any pilot's license at all. And so that is kind of part of the pilot profile. So depending on what the customer's needs are for the map, we can get them pilots that are maybe have an exemption and do have a private pilot's license. Did that answer your question?
Yes.
Yes, sir.
You have 3,000 pilots, you said, in your system. Are they in fact customers?
Are they in fact customers? So our system's a service. So basically what we're doing is we're charging for data processing and access to the marketplace. The pilots themselves have the ability to create pricing.
And they own the drone and they have the customer.
They do own the drone, and I would say the customer is more of a joint relationship because the customer's information is going to be hosted on our dashboard. And really it's easy to use for the customer. As you look at large construction companies like the BART project I showed earlier, they have now been flying for almost 6 months, and they're now into the terabytes of data. So for our pilots that are doing this, it really makes sense to kind of have that data processing and amount of data land on our side of the table, because very quickly it gets to be unmanageable. And the way that you can give it to the customer on the dashboard is a very simple interface for them to pull out the data they need without having to really access the database. So.
But if I wanted to be a pilot, I'd have to own a drone, or can I come to you and say, hey, I know I'm a pilot, here are my certifications, rent me the drone, rent me the program?
No, we don't rent out our hardware. So the SkyCatch unit itself is not part of the work mode program. The work mode program is built around whatever the pilot's own UAV is, which gives them the opportunity to use anybody's platform here. And we basically provide the back end of their processing.
But that speaks very much to the ease of use of it, of your software, obviously.
Exactly. It's, we do have requirements. You know, we have basic requirements as far as front lap and side lap as any photogrammetry software needs. And then the geotag images are another big requirement. But besides that, they can fly whatever drone they want that can capture that image. Capture it. Let's go with you, sir.
How do you price your data processing?
So we do have pricing. I'm not going to go ahead and say it here. It's available online. But you actually have to go through, it's a monthly model. So you basically pay a subscription fee, and it gives you access to the dashboard for all of your customers. It gives you access to the marketplace and data processing. We do scale it, so if you're under 10 maps a month, you pay one price, and if you go over 10 maps a month, it's another price. Besides that, it's only 2 prices. And did that answer your question, sir?
When you say geotagging, you mean the coordinates on the line platform and or like ground control points that can be attached?
Good question. So ultimately, we need metadata from the lat long stored embedded in the image, right? Ground control points can be used, but they're not necessary. We have basically, since the images are geotagged, what we can do is that we already know where each image is, so we can have a general alignment of the map. We actually will compare it. When you look at our dashboard, it's overlaid over Google Earth. And as we use the computer vision tool to basically line up roadways, as well as deal with any change detection that we need to do as well. So it kind of snaps the map into perspective. Now, if the customer is looking for a survey grade map, or they want access to a point cloud, then absolutely we need to basically have ground control points on there. To give you an idea of how we handle some of our ground control points, we actually have something called April tags. I don't know if anybody knows what they're called. It's a QR code. And basically what this is a very large QR code that gets laid on the ground. And as the pilot flies over it, the system can auto-recognize it, and then the pilot uploads. So the ground control point 1 has whatever local coordinates, or if they want to do lat long, and then it automatically ties it into the system and produces a 3D map. How are you doing on time?
You actually have like 3 minutes.
Okay. Any other questions before we wrap up? All right. Thank you for your time, everybody.
Yeah.
You can use yours, go ahead, if you're more comfortable, doesn't matter. We save the best for last. Aviator, Austin, ready? Looks like you're back here. All right. 1 second, please. There's your Clifford. Joy.
Thank you, Patrick. My name is Austin Jensen. I'm a research engineer at Utah State University, and I'm here to talk about a program we have at the university called AgAir. Basically, AgAir was started about a decade ago. We have a water research lab at Utah State, and part of the Utah Water Research Lab is precision agriculture and irrigation for agriculture. And so the director of that lab 10 years ago saw a need for high resolution, up-to-date aerial, multi-spectral aerial imagery for precision ag. And so he approached my professor at the time, and who was in robotics. That's my background initially, and basically said, hey, here's these flying robots. It looks pretty easy. Why can't we just put a camera on there and fly around, take some pictures, and do precision ag? Well, turns out precision ag is actually one of the hardest applications for remote sensing and aerial imagery. And so we kind of got started with that. That was our initial motivation. But in the end, we actually also developed in general for natural resource applications. And initially, that's kind of what we targeted first. So AgAir it's not a consumer grade platform. It's more of a commercial grade scientific platform that we target for use in scientific applications, natural resource applications. And so, for example, this is us on the North Slope of Alaska, flying over a river in support of a faculty member at Utah State who's doing some research in mass heat transfer on that river. And so she was really interested in not only the visible, but also near-infrared and thermal imagery. And she really wanted to know the thermal imagery of the river. And so this is one of many, many applications we've been involved with. Another one is here in Utah, where we're flying an air quality sensor measuring ozone over some gas fields, because there was a serious air quality problem over here. And basically, NOAA and all these other people were there trying to determine whether the air quality problem they were having is a direct result of the mining and oil and gas operations going on there. Lots of stuff with rivers. So we do a lot of stuff with fish habitat, mapping mesohabitat, thermal refugia. I mean, the list just goes on and on. Flying over wetlands, mapping vegetation, and of course, eventually we did go back to ag. And so, since there's a lot of, everybody's really excited about precision ag, and since we started, we haven't gone back to ag because we were able to add thermal cameras and other things. So that's basically, I'm going to be talking mostly about ag. If you're interested in other applications, natural resource applications, we'll talk about that as well. But so basically, we view AgAir as a piece of field equipment, right? The scientists, the researchers, they go out and they have their RTK GPS. They have their sophisticated tools. This is just another tool to add to their list of stuff. So it's got to be able to land and launch from anywhere. This honestly is a pretty ideal location. Even the North Slope of Alaska on the tundra is pretty ideal. It's like a big mattress out there. But we've also flown, in Salmon, Idaho, that previous picture, that was very mountainous. And so we've had to deal with a lot of varying terrain, a lot of varying different areas, and we've always been pretty successful at launch and landing. It's fully autonomous, so eventually we really want people without engineering degrees to use these. So it's got to be fully autonomous. The launcher helps with that. It lands fully autonomous. It flies around with a pre-programmed flight plan. And then the other really important piece is that it's multispectral. So we started with this in the very beginning. We said, if we're not capturing visual and near-infrared data at least, then we're not doing science. So we might as well not fly. And we've also been able to add thermal. And so we fly with all 3 cameras on board, and we capture all 3 of this type of imagery at the same time. And that's really important for the types of applications we're involved with. So here's our aircraft. We actually have a roof, and I'm pretty sure most of you have seen it. It's pretty standard, fixed wing, have flaps, pro on landing, etc. And all of this has pretty much been developed at Utah State. A lot of this is student projects, and the students really get a good hands-on experience. The aircraft itself is a student design, the fuselage of the wing. We have students that do composite work, and they get really good at composites. So we're developing a really good system, but we're also doing a really good job educating students and giving them real hands-on experience. So, you know, this is a pretty standard unmanned system. I'm not going to spend a lot of time on this since we're all pretty familiar with the operations, but you program with a flight plan. And then this is a slow-mo video, but this is the launcher. By the time it leaves the launcher, it's moving at 40 miles an hour, so it's pretty cool. That was actually a senior design project, one of the most successful ones we've had. And then, of course, while it's flying around, it's taking pictures. And every time it takes a picture, at the very moment it exposes, we record the GPS and orientation data. And then we also get telemetry, right? Here's our ground station. We want to be able to see it, where it's going, what it wants to do, and just make sure that it's operating as it should. And then we should do skid landing. So to slow the aircraft down far enough, we have Pro, which is flaps down, ailerons up, elevator down, and that's been pretty successful. So data processing, this is also pretty standard. Most of us are pretty familiar with it. So right after the flight, we have our raw imagery. This is kind of what it looks like. And remember, every time we expose, we record this data. So basically, we project that image onto the ground. It's called direct georeferencing. And we get something like this. And obviously, it's not perfect. This is immediately after the flight. So it's very timely, but the position accuracy is pretty poor. But we use this to check overlap and some other things. And so to really get a scientific grade product, obviously you have to go through the mosaicing process. And so this is usually relatively timely. It takes a lot of time, depending on your experience and depending on the software. But most of the people, they want most of the scientists, researchers out there that we support, they want the best, highest quality mosaic we can possibly give them. And they're going to take this mosaic and they're going to overlay it on their base map. And if it's off by a little bit, they're going to complain. And so we spent a lot of time and effort to make sure that our mosaics are good enough so that they don't have problems with them. And then, of course, one byproduct of the mosaicing process is a digital surface map. And so we use that for applications as well. So, all right. So, ag gear is obviously we've done a lot of work on the aircraft, right? But honestly, it's not that hard to build an aircraft, to build an unmanned system, and strap a camera on and take pictures, right? The real hard part is capturing good quality data during flight and what you do after the flight. That's the challenging thing. And so that's really what we focus on. We have 2 PhD students currently working on this, on precision ag and processing the data. And we have so we get the multispectral images basically, right? So this is a project we had a couple years ago over some center pivots. And we did this over the summer a couple of times. But basically, we fly and capture the data, make mosaics, and then we can do the standard thing, which is let's produce some indices, right? So most of us are probably familiar with ADVI, normalized vegetation defense index. And a lot of times when people say they're doing precision ag, they make the mosaics and they make the ADVI and they say, okay, here you go, precision ag, good luck. grower, good luck farmer consultant. Unfortunately, we don't really believe that's the end result, and if you give that to a farmer, he's going to feel a lot like this donkey, overloaded with data that he can't do anything with. A map is useless to a farmer. He needs, the information needs to be processed a lot further in order to be really useful. And so we go a lot further, and we can generate maps that represent real plant nitrogen. Okay, so instead of NDVI 0 to 1, 0 bad, 1 good, very relative information. Yeah, you can kind of see where the problems are, but you can't answer the problem. What is the problem? Why is it there? So we take it a lot further, and a nitrogen map explains a lot more and it gives a lot more information about, is this a fertilization problem, right? Because if you see a problem with an NDVI map, it could be an irrigation problem, it could be a fertilization problem, pest problem. There's lots of problems. It could be a soil problem, right? And so the nitrogen map gives some sort of indication, is it a fertilization problem? With the additional thermal, we can do irrigation sorts of things. And this is evapotranspiration. So this is a map that we've produced. An evapotranspiration represents the amount of water leaving the system. And again, we're not talking about relative 0 to 1. These are actual units, millimeters per day, of absolute measure of information there. And then we can go a lot further. This is soil moisture, right? Root zone soil moisture, this is top zone soil moisture, root zone. And so this is a lot more valuable, and this kind of information can be used to generate irrigation schedules. We can generate forecasts of this and irrigation schedules. We've also done some work with vineyards. This is actually a vineyard here in California, and we did the standard thing. The difference here in this project is that we flew in the morning and in the afternoon. So you can see the thermal. This is the morning thermal and the afternoon thermal. And the difference really gives us a lot of added value. And then we did the standard thing here. NDVI, Invariant Index, Health Vegetation Index, and then this is ET again, right? And so we did the same sort of things. However, the additional thing we did on this project is we used the digital surface map that we got. And you can see here, you can see the individual rows on the vineyard. And you can basically interpolate the terrain, right, underneath the vineyard. And so the brown here is the terrain, and then the white is the canopy, basically. And with this kind of information, we can map each individual vine on each row, and then we can actually do volume calculations. So this is crop canopy volume. And each one of these polygons is an individual vine, and the color represents the volume of that individual vine. And so the cool thing is volume can be used for yield prediction, right? Obviously on vineyards it's a little more complicated than that. However, what they're really interested in is, okay, where are the dead vines? Where the line, you know, and so these sort of things can help with that. So this is pretty cool, right? I mean, we've gotten really far in providing really valuable information to farmers. But is it a viable business? So this is where we're at. And to this day, I have yet to see anybody else that has gone this far as we have to provide this kind of information. Unfortunately, this is not even far enough yet, right? So we need to be able to convert all these soil moisture products into a forecast, canopy volume to yield, plant nitrogen and fertilizer. But even this isn't the end. This is what the farmer really wants. This is what he's looking for, not a map. He's looking for an irrigation schedule, right? If he flood irrigates, he wants to know when should I ask the canal operator for water. If he irrigates via pivot, maybe program his pivot or suggest when he should water. There's no maps involved with that. Yield forecast, there's no map involved in your yield forecast. Maybe he uses the yield forecast to divert resources or to, I don't know, I mean, there's lots of ways that you can use that. And then for a prescription map, he's not going to take a bucket, right, and go out to all these areas and dump fertilizer with his GPS receiver. you're gonna have to program this tractor. And so, for a real viable business in precision ag, delivering actionable information is still a really big problem, not only for everybody out there, but even for us. Everybody has this problem. The other issue is taking action on that data. So, does the farmer even have an autonomous tractor? If he doesn't, and I sell him a system, and he gets all this data, but he's gonna get mad because he can't use it, right? So I think as a community, we focus a lot on the sensing and delivering the information, but we're not worried about actuating on the data. That's his problem, right? But I think that'll come back and bite us in the future. So how are we going to take action on the data? We need to be concerned about how the farmer or the company is going to take action on that data. Timeliness is still a really big issue. Remember, this requires 3 mosaics, what we're doing. And you know, we played with a couple of different mosaic software, and you can make a pretty picture pretty easily, pretty quickly. But see, these guys aren't interested in pretty pictures. They don't care about pretty pictures. They want real quality data. And to give them quality data, it takes time to make the mosaic. And so, if you deliver an irrigation schedule, for example, in a week, it's useless. You have to deliver that in less than 12 hours. Minimum viable flight time. No, forget flight time. Flight time doesn't matter. What matters is coverage. There's a minimum viable coverage area for ag. And this is really misunderstood. Real ag isn't hundreds of acres, it's thousands. Right? And if you can't cover enough area, then your product is useless. And so 2,500 acres, that's the average size of a vineyard in California. And so there's bigger plots and there's smaller plots. And every time you take off the land, it's gonna cost money. So the more you can stay from the area, the more you can cover, and there's gonna be a minimum viable coverage area for that. This is still a big issue, right? 2,500 acres probably doesn't include most seed tools out there. It's gonna be unfortunately basically there. And I'm sure there's really big weed tools out there, but even the fixed weeds, the smaller ones especially, can't cover this kind of area. So it's a real issue, and that's going to be a challenge for all of us. And then there's also minimum viable flight altitude. So everybody likes to fly 400 feet, 500 feet, but unfortunately that has some bad effects. First of all, it affects your minimum viable coverage area. Our platform, it can fly for an hour, and we can cover 2,500 acres, but not at 400 feet. We have to be more at 1,000 feet to actually cover that amount of space. So your altitude affects the amount you can cover. The other thing it affects is the quality of the mosaic. So the lower you go, the more homogeneous your images become, the harder it is to make your mosaic. And the more suspect the quality of the mosaic becomes as well. So basically at USU we're continuing looking at these challenges, and we're going to continue to solve these problems. And anyway, that's all I have. Any questions? Yep.
Austin, you projected a set of data, raw data, funny blue pattern on the screen, and then you projected hard numbers after it, having to do with water content. How did you calibrate the data to get the real, quote, real number, unquote?
Yep, good question. It's all, at this point, a matter of ground sampling and modeling. So there was some ground sampling involved in all of those products. And then we have some sophisticated methods to do the modeling. And we have PhD students on this that are giving the dissertations and publishing journals at this very time.
Okay, but you start with some known, like the soil and various things.
Yeah. Any other questions?
Your infield check before you do a mosaic. Can you describe that process?
The flight planning to make sure that we get a mosaic?
No, when you land and you have the individual photos, you showed a quick overlay.
Okay. Yeah, I mean, basically it's just a matter of downloading the data. And then since we have the images, we have the position and orientation, it's just a projection. If you're just projecting the image on the ground. It's just geometry, and it's pretty simple. There's a couple of papers out there that describe the process, and if you'd like, I can show you those later.
All right.
Thank you.
Okay, that is year 3 is now in the can. And I hope that everyone came here, and I unfortunately don't get to watch the presentations. I'd like to, but I have a few things going on. But interesting conversations, interesting networking. I really, we strive to try to give people that type of experience coming here. I know that a lot of the exhibitors have done some business, done some networking with real companies. I hope that it was worth it for everyone to come out, and that we all learned something and met people that we'll build relationships with and can do business with, and grow this community. And I want to thank everyone for coming out to the Small Unmanned Systems Business Expo. And that concludes our program, so have a nice day. The postcards on the table have the dates for next year. If you want to pick one up on the way out, it'll sell out early, so reserve your ticket today. No, just kidding. Tickets later. Oh, okay. Well, I didn't get a chance. I was at my wife. Yes.